Hey, hello, good morning, everyone. So, it is 9 a.m. now. Okay, but I think we wait for another maybe 5 to 10 minutes, yeah, because I think we still have around 10 participants, okay, that they might join the session. All right. So we will start in 5 to 10 minutes time. Yeah? Thank you. Hey, I think we have a good number to start now. All right. So again, good morning, everyone. Okay, I'm Ju. Okay, so welcome to this your module. Okay, statistics for data science. Right. So a bit introduction about myself. Okay, so yeah, I'm from USM. Okay, and my research area is on stats and also advanced analytics. Okay, so yeah, this is the link to my profile, and also maybe you can scan the QR code to access my profile. Okay, just maybe there is some collaboration opportunities or research opportunities, okay, that we may take on. All right, so feel free to take a look on it. Okay, so this is the agenda for this two session, okay, for this module. Okay, so for the first day, okay, for today, okay, you're going to learn about the introduction to Python, Anaconda, and Jupyter Notebook. Okay, I believe you have already learned this in your first module, so this will be a very quick one. Okay, so and then you will learn about the essence, okay, for this module, okay, which is commonality analysis. Okay, then under commonality analysis, we have EDA and CDA, which is the exploratory data analysis and confirmatory data analysis. Okay, so we will learn about the EDA today and also the first part of the CDA today. Okay, so the remaining one, okay, the confirmatory data analysis part two. Okay, you can't hear. Oh, can't hear me. So how about the others? Can you all hear me? Oh, can. All right. Okay, thank you very much. Um, Kamaru, maybe you might want to log out and then log in again. Yeah, because yeah, thanks for your response. Okay. So yeah, you have any, yeah, maybe you can log out and then log in again. Okay. So where am I just now? Okay, so about the CDA part two. Okay, so CDA part two, we will learn in the next Saturday, the coming Saturday. All right. Then finally you will learn how to combine, okay, all the knowledge that you have learned in these 2 days, okay, and then apply it to a real world use case or real world projects. Okay. So for this module, okay, for this module, we are not going to focus a lot on the theory. Okay, not to focus heavily on the theory, okay, but more towards application. Okay, towards application. So because we only have 2 days, okay, and then we have a very limited time, okay, and then yeah, all of you are working adults, so I believe your expectation is also, to learn and to apply to the data set that you have in your hand, you see. So yeah, the theory part usually maybe uh undergraduate, or you have learned in your undergraduate or maybe your secondary school, you see. So now we are going to learn how to apply them, okay, to apply them to a real world use case or the real world projects. Okay, so that is the main goal for this module. Okay, but in order to reach that steps, okay, you also, of course, you will need to pick up some, some statistical terms, some basic theories, all those. So I will walk you through the simple theory. Okay, then we will, do some hands-on, do some application wise. Okay, so that's the first thing. And then second, for this module, okay, you will be exposed to two statistical tools. Okay, so first is Python, Jupyter Notebook, and Anaconda. So this one you have learned in your first and the second module. Okay, and then the day two, which is next Saturday, okay, you will learn about this jump tools. Okay, JMP jump tools. So you might want to ask, okay, why you are being exposed, to these two tools, okay, in one module. You see, so actually I really hope that you can get exposed to these two tools because both to me, personally, I think both is they are equally important. You see, so you learn how to do stats by using Python is because you will proceed. Okay, so stats usually is the first part. Okay, the first part of EDA, let's say exploratory data analysis, is your first part of your experiment. So before you go into machine learning, usually you will start with exploratory data analysis. You see? So machine learning, usually you will use Python. Okay, you use later you will learn deep learning as well. So you use Python, right? So it's good if, let's say, you know how to do stats, okay, how to do stats in Python so that it can be carried forward later. So you do data analysis, then you continue with the data analytics. Okay, so it will be end-to-end framework in one tools. Okay, so that is one. So that's why um I hope that you know how to do stats by using Python. Okay, so for jump tools, for this jump tools, actually is a very famous and very popular statistical tools. Okay, that has been widely used in the industry. Okay, so actually there are many international company that has they already subscribe to these jump tools. Okay, so please install this to your machine. Okay, we are going to use it next week. Okay, the installation guide has been provided to you in the e-learning portal. Okay, you can refer to it and proceed for the installation. Yeah. So for this jump tools is very user friendly. Okay, and you don't need to write code. Okay, so you know you might prefer to use these jump tools. Okay, you might want to use. I mean, if it's good for you to know. Okay, so if let's say you just want to do statistical analysis, okay, not analytics, you want to do only simple stats, okay, or maybe you want to do only the commonality analysis, then it's good lah for you to get to know these jump tools because it's very easy, just a few button clicks, then you're able to get your results and your conclusion. So it's very good for you to get to know these statistical tools as well. Alright, so that's why for today I'm going to introduce you both tools. Okay, one is a free one is a paid one. Okay, and then one is for your maybe end-to-end framework. Okay, if let's say you want to continue further for data analytics, then you might want to use the Python. Okay, for jump tools, if let's say you want to do one-off experiment, then it's good enough for you to use this statistical tools. Okay. As one question, is there any tools widely used? Yeah, there are a lots of statistical tools. You have Minitab, you have SPSS, you have Mathematica, you have MATLAB, so many. So to me, because I'm from before I joined USM, I'm actually from industry. So from industry, the tools, the statistical tools that I can see, that is heavily used or widely used there is jump jump tools. So nowadays also the very widely used because it's very user friendly and easy to use. No need to have a very strong programming background. Okay, you can also conquer this tool very well. So that's why it's being heavily used. But yeah, SPSS is to me it's more on research wise. Yeah, if let's say you do research or in students perspective, then yeah, maybe SPSS will be yeah, maybe it's suitable. Okay, Minitab, Mathematica, MATLAB, all those you also need a little of programming. Okay, not too much, but a little. Yeah. So yeah, to me they're the same. You use this all these two, you will get the same result. Just yeah, according to your preference. Yeah. But most of them also is a paid version. MATLAB, you might get a basic version, okay, without the payment, without the needs to subscribe it in. Yeah. But Jump, of course, you will need to subscribe, but they give you the free trial version for a month plus a week, if I'm not mistaken. Yeah. So yeah, I mean it's good to try. Okay, and you can do simple analytics by using Jump, okay, but not other statistical tools. Yeah. So later next week, you try. Okay, you try and see, and then you have a feel on it. Then you see whether it suit your taste or not. All right. Okay, so that is about the intro lah for the agenda for this 2 day. Okay, and then this is the agenda for these 2 days. Okay, so you will have a morning break, a quick break, maybe a toilet break. Okay, 10:30 or to about 20 minutes to 10:50. But this one we will adjust accordingly based on the progress, the suitability. Yeah. Then we will have a prayer break from 1 to 2 p.m. And then finally we will have another afternoon break lah, 3 to 3:50 like that. Okay, about 20 minutes break. So yeah, maybe for today we will try to see whether we can wrap up early, like maybe for something, you see, because yeah, okay. So yeah, so far you have any questions that you want to ask regarding the agenda for these 2 days? And yeah, this is the data set, yeah, before I forgot. Okay, the data set that you are going to use today, okay, for the hands-on session. Okay, so the link has also been posted in the e-learning portal. Okay, the slides and also the link. So you can just click on the link and you can download all the materials there. Okay, so yeah, so this is the agenda for these 2 days. You might want to load it to your machine first, the data set, because yeah, later it will be I mean you can just use it during the hands-on session. Yeah, because it's a lot. So it might take some time. Okay, and also we were going to use hands-on session after the morning break. Okay, so you might want to launch Anaconda first in your machine. All right, so we're going to proceed to the pre and the post test. So sorry, this is the pre-test. So pre-test for this module, like I mean like the previous two module, you will need to do a pre-test and a post-test. Okay, so pre-test we do before we start the session. Okay, half an hour. Okay, I will launch it okay now. Okay, in the e-learning portal, you can refresh, then you can see it under the installation instruction. Okay, so you can start the test now. You have 30 minutes, and then the post test will be having it at the next week. Okay, maybe before the session end by 3 something or 4. Okay. So you will have a pre and a post test. The question will be the same. Yeah. All right. So all the best, okay, for the test. Okay, and I will see you after 30 minutes. Thank you. We have seen this our friends Hanim say that you cannot go into the pre-assessment. Why? You can just go to the refresh your e-learning portal. Refresh. Then you can see the link of the pre-assessment under the tab for the installation guide. Okay, then you just click on it, then you're able to do it. I can see all of you already halfway. Yeah, thanks. Hey, hello everyone, welcome back. Right. So I can see yeah, most of you have submitted the your answer. Okay, thank you very much. Okay, for completing the assessment. All right. So I think now we can move on. Okay. So yeah, before we go into the lecture, okay, for stats. All right. So I would like to share with you some of the real life data science projects. Yeah. So these are the projects that I worked before, okay, from industry and also some from my research. All right. So as I know, okay, you will need to come up with a project. Okay, you will need to do a project at the end of this program, right? So hopefully, okay, with this sharing, okay, it will give you some kind of ideas like what kind of data science projects that you can actually work on. Okay, maybe you have this kind, the similar data in your hand. Okay, so you might want to consider to do something like this, or maybe for your future reference. Okay, so yeah, the first example. Okay, so for the first example is about the domain is on HR. Okay, so previously, what we did is we have a department, okay, works on analytics use cases or analytics projects. So if the other department they have issues or they have problems, then they will come to us and ask whether we can use analytics to help them to solve the issues or not. Okay, so this project is from HR, okay, this department, where they face two main problems. Okay, the first problem is to um, slow to fill skill demand. Okay, so in a multinational company, okay, so they will have many requisition or I would say vacancy. Okay, there are many vacancy in a multinational company. So the problem that they face is very slow to fill the skill demand, which means okay, so the normal process or the manual process will be um, they will send, I mean, they will, if let's say there's a new vacancy coming in, so the hiring manager will request from the HR department saying that, okay, I will have this vacancy. So can you share with me the suitable candidates, okay, to be interviewed or to proceed further? So the HR department will process, okay, will process all the resumes that they receive. Then they will send the suitable candidates, okay, to this hiring manager. So the hiring manager will process, okay, and then they will select maybe the top three or the top five candidates to be interviewed. Okay, so the whole process will take about a month, okay, to really hire the people and close the case. Okay, so to them is very slow, okay, and it's not effective lah, because a month, okay, is too long for them. Okay, and sometimes they will find that when they hire the people, okay, the people is not the people that they want, okay, because they don't have the skills that they need, something like that. This is the first problem that they face. Okay, so second problem is the role model and productivity. So for this problem, okay, they face is so in a multinational company, okay, usually they don't encourage their employee to stay in the same department, okay, same department for too long. Okay, for example, okay, if let's say you have worked on the same position, okay, for 10 years, 20 years, for this multinational company, for them is too long. Okay, so they would like, they will encourage their employee to have maybe internal transfer, or maybe internal switching between I mean in the department, okay, or maybe yeah, among the departments. Okay, so and also if let's say some employee, okay, they have worked in the same position for let's say 10 years, 20 years, and they think that there's no more room for them to improve. Okay, I want to switch. Okay, I want to change, job, but I don't know which kind of job is suitable for me. So I dare not step out to try new things. So I just remain on the same position. Okay, so when you lost your passion, okay, you lost your passion, you just want to get things done and get your salary, that's it. Okay, so you won't do much. Okay, there's no more innovation or no more passions, okay, that can be mentioned. Okay, so for this case, okay, it will lead to the role moral and productivity. Okay, I don't like my job anymore, or maybe I want to switch, but I don't know where to switch. Okay, so this will lead to this low moral and productivity. Okay, so they ask us how can we help, okay, by using data science. Okay, so for these projects, okay, we ask them, okay, we ask them what kind of data that you can provide to us, and this is the data that they give to us, which are the resumes. Okay, so imagine if let's say multinational company they receive so many resume in a day. Okay, so maybe 100 over per day, or maybe 50 something per day, and they give us 3 years data. So you can imagine how much data they give to us, and this is the first challenge that we have, which is the volume. There's too much. Okay, and second is the unstructured data. So for resume, actually it belongs to unstructured data because different people, you write your resume in different way. Okay, so some people they will send in their resume in Word file. Some they might send in PDF file. Okay, some they might send in Excel, or they might create their resume by using other tools like Canvas, all those. So different formats resume that we receive. Okay, so this is a very unstructured data. This is not in rows and columns. Okay, so this is the second challenge that we have. And then the last one is the complexity. So complexity, it means, for example, if let's say, different people write in different way. For example, I write Java programming as JAVA programming. You might write Java programming as JAVA in uppercase. Okay, and then I might write in lowercase, and he might write as a J programming, or the programming is short form. Okay, so how are we going to tell the machine saying that all these words actually belongs to the same meaning? They have the same meaning. This Java programming, J programming, all of this, they are the same. Okay, so how are we going to teach our machine saying that this are the same meaning? Okay, so this is the third constraint or the challenge that we have. Okay, so from here we extract out the data because we have to put it into table form, the structured form, then only we can proceed further. So this is just part of the very little part lah of the data, and you can see it's a very dirty data set. Okay, there are so many annotation, all those, so it's a very dirty data set, okay, that we have to work on. So the goal for this project is to have high inferential power, which means we have to create a back-end infra, okay, a back-end infra to run the experiment, because we cannot support this experiment by using our own machine. It will crash. It's too much. The data set is huge, so we cannot use the normal machine to proceed. Okay, so high inferential power, we have to set up a back-end infra to support the experiment. Then we do a more accurate job matching, which means we help them to match the right people to the right vacancy, the right job. Okay, and of course it will be increase the efficiency and gain velocity, which means it will be much more faster. Instead of only a month, okay, instead of a month, okay, maybe just one button click, then they can get the desired or the suitable candidates to be interviewed. Okay, so speed. Okay, so these are the solution that we suggest to them. Okay, so backend infra, we help them to set up a Hadoop cluster here to support their experiment. Okay, and for this normalization is the one that I mentioned. Okay, we normalize all the words. For example, the Java programming, the uppercase, the lowercase, the short form, all of those belongs to the same meaning. So we use normalization, and we do NLP, natural language processing, and also analytics to perform the job matching. Okay, so these are text data. Okay, so these are the sample results. Okay, we already anonymized it because yeah, of the confidential thingy. Okay, so this requisition one is the vacancy that we have. Okay, the first requisition, and these are the resumes that we receive, and we match them to the requisition. So when there is a new vacancy coming in, Okay, we will match their resume to the requisition. Okay, and these are the scores. Okay, these are the scores that we have. Okay, so for example, the first candidate resume number one. Okay, this requisition one. Okay, actually we need these skills: machine learning, Python, R, SQL, and Tableau. Okay, we need all the skills. So this first candidate fulfill all the skills, you see. So you get 100 marks, which is one score. Okay, so second applicant only fulfill 4 out of 5, so you get 80 marks. Okay, so same goes for the remaining. We count by using the same principle. So instead of going through and forth from the HR department, you can just use one button click, then you will able to get the score accordingly. Okay, then the manager can proceed to interview the top 3 or the top 5 candidates from here. So this is the dashboard that we built for them. Okay, so we have all the candidates and all the requisition over here. So just one button click, they were able to get their the suitable candidates. Okay, so they can just click on the resume, and the normal information, the basic information will be showed in the dashboard. So they can just proceed to call the candidates or email the candidates and then proceed to the interview. Okay, so yeah, this is for the first problem. So we help them to solve the first problem, okay, which is to increase the speed, okay, to hire people. Okay, so second one is about second problem. Just now we have mentioned that you want to switch, but you don't know what kind of position that is suitable to you. Okay, so we built this employee dashboard, okay, for their employee. So they can match themselves to the existing vacancy. Okay, for example, this Peter, okay, he matched himself to the requisition, and you can see, oh, actually I fulfill the requirement for requisition number one, is it? So yeah, I match all the attributes, so maybe I can apply for this position, this job. Okay, so second one, I fulfill also requisition number 7. So I might want to try this, try to apply for this position. You see? So this is the first one. It can help them to solve the problem where they want to switch, but they don't know where to switch. You see? So second thing for this dashboard is good for the personal growth as well for the employee. Okay, so as you can see from here, if let's say this Peter have a dream to become, let's say, a data scientist. Okay, a data scientist. So let's say requisition number 3 is a data scientist, okay, position. So Peter will know, okay, I what kind of skills that I need to polish up, okay, in order for me to achieve this position. You see? So Peter only match one skill, and he need to polish up skill 11, 12, 13, and 14. You see, so it's a very clear direction for the employee to upgrade themselves. Okay, they might want to upgrade themselves, polish up their skill 11 to 14. You see, so actually it's a very good indicator for them, for their personal growth. Okay, so yeah, because sometimes you might want to achieve something, but you don't know how to start, and you don't know what is actually needed. You see, so with this system, then the employee will manage to do that now. Okay, so this is the dashboard that we built for them to solve the second problem. So for the first example is about the text data. Okay, so if you have some text data, okay, you might want to consider to do some text analytics. Okay, so second example that I would like to share with you is about the tabular data set. A tabular data set. So for this example, okay, this project, the problem that they face is first they keep on hiring people. Okay, the pay is good. Okay, the salary is high, but then they don't know why. Okay, after they train them for some time, okay, and they think that okay, the person is now ready to contribute back to the company, because when you hire new people, they cannot perform immediately. Okay, you need to give some training, some time to boot up the people, okay, the employee, then only they can start to perform. But they notice that after they spend some time, to equip them, to help them, to train them up, and finally the employee tends to leave the company. So they don't know why this happened. Okay, why I train you so well, okay, I give you so many trainings, etc., then finally you leave the company. So this is actually a loss for the company, you see. So when I spend amount to train you and then finally you leave, then it's actually a loss for the company. So they want us to help them to identify the main factor. They want to know why this employee tends to leave. Okay, they want to know why. And they want to predict the employee retention period. So they want to know when their employee is going to leave, or when they receive a resume, okay, how long this employee or this applicant will stay in the specific department. You see? So these are the two main objectives that we have for this project. Okay, so this project is not to to act as a to penalize anyone. Like, when I notice that you only will stay in the company or the department for 1 month, then you're going to get something, or I'm going to do something on you. Okay, so this is not a system to have this kind of bias uh perception, okay, to penalize anyone, or to say, I mean, to do anything on anyone. But this is a system for them to do to have a proactive action rather than reactive. Okay, so the meaning of proactive and reactive is proactive meaning you know that thing will happen, okay, and you do an action to stop that things to be happen. For example, you have a very important people in the department, and you notice that based on the prediction, you notice that this people is going to leave. Okay, so you know that this is a very hard find skills. Okay, the people is very important to your company. So you might want to do something. Okay, the management might want to do something to retain the talent. Okay, it's a proactive action rather than reactive, meaning, for example, I mean, when people tender the resign letter saying that, okay, I'm going to resign, usually people already get other job, other offer, sign the agreement. So it's very difficult, for the management to do something to retain the talent at that time. That is a reactive action. So when the things happen, then only you figure out what is the solution for that. You see? So for this project, we aim to help them to be proactive rather than reactive. Okay, so the key findings, you know, one interesting facts to share with you. So different department, you will have different results. You see, different data set, you will get different results. So for this data set, we actually found out that the salary is actually not the determining factor. Okay, it's not the factor that actually affect the people to leave or to stay, but the gap between the reporting manager and the employee, plays important roles. For example, if let's say a fresh graduate, okay, they join the company, okay, and we will have a reporting manager, right? So if let's say you report to a CEO, you see, so a fresh graduate and a CEO, their gap is very huge. So the employee tends to leave. Okay, but if let's say a fresh graduate, you report to maybe a senior or junior manager, you see, or maybe some seniors engineers or something, they are seniors. So the gap is smaller, so the employee tends to stay. Okay, so that is the key findings for this project. So these are the data set that we work on. Okay, we have received many features from them. Okay, many features from them, and we help them to analyze this and determine which factor is the key factor that actually make this employees leave. Okay, and we also help them to perform the prediction, predict the number of years, okay, that the employee will stay in that company. So they just need this is a dashboard that we built for them. Okay, so by pumping in the data, okay, so they will know how long the employee will stay in the company. Okay, so 10 years, 5 years, 3 years, 1 year, or few months. Okay, so from here, um, the management can actually make some decision based on maybe this one is as a guideline for them, as a guide for them or reference for them. Okay, so that is about the second project. Okay, so the third project that we work on is on the healthcare domain. Okay, so healthcare domain, for this one we work on a prediction, okay, on the HCC, bone cancer. So for this project. Okay, so our main objective is to identify the main features, what actually causes this type of cancer, and we help to perform the prediction. Okay, we want to predict whether the patient will survive or die, the prognosis of the patient, and also of course to gain velocity and to help them to build the dashboard. So these are the data set that we use. Okay, it's not tabular data, but in CSV form. So these are the features that we have. And finally, the target, our target, we want to predict whether the patient survive or die. Okay, so these are the data set that we have. And this is the dashboard that we built for them. Okay, so they can pump in their data, upload their data set, and we can predict whether the cancer patient will survive or die. Okay, so this again, this system is not to penalize anyone. Okay, if let's say the status is survive, it doesn't mean that the patient will really survive. Or if let's say the status is die, it doesn't mean that the patient will really die. You see, so this is actually a proactive uh, system. Okay, for them to do the proactive action, for the maybe to act as a guideline for the physician. Okay, for example, if let's say the status is die, then we might want to find out the factor, okay, that actually cause this status. For example, it's because of obesity. Okay, so the physician might want to suggest something to the patient. Okay, saying that you might want to do something to reduce the weight or something, so that after a few weeks or a few months, the patient come back and scan again, okay, do the pump in again the data set, the status might change to survive. You see, so this is a proactive action. Before it happens, we solve it, and we save I mean the ending. You see, rather than the things happen, then only you go and find out why this patient will like this and something, but it's already too late. You see, so maybe it's because of smoking or because of diabetes or something. Then suitable medicine can be given to the patient, okay, to control, and then they do a test again after a few weeks or few months, then the thing might change. You see, so this is actually a proactive action rather than reactive. Okay, so we also apply similar machine learning model to predict different diseases like heart disease, cardiography, and then leukemia patient. Okay, so this is the third projects, okay, that I would like to share with you. And the final one, okay, the last projects that we work on is on the industry. So this project is still work in progress. Okay, is we not yet completed this project. So the problem that they face is actually the time to fill is too long. Okay, so for this department, okay, they do assembly. They assemble material. They have different materials, then they assemble them together. Okay, and they put them together, then make it as a product, then they ship to the customer. So the main problem, the main issues that they face is the order time is very long. Okay, they have different materials to be contained, okay, to be merged together. So you know, some materials might need months, okay, to be shipped to their factory. Okay, so if let's say a customer say I want this product, I want it within a month, but the materials will take 2 months or 3 months to be shipped to the department or to the factory. You see, so they cannot fulfill the requirement of the customer. So it's a loss for them, lah, actually. You see? So they asked us whether we can help them or not, okay, to solve this problem. So we collect some data, okay, the historical data from them, and we want to help them to predict the demand. Okay, the demand. So before the demand come, before we know that there will be order for this material, this part, or this something, so they already order it and then they keep as an inventory. Okay, so when the order come, the demand come, then they can just concate and they can ship to the customer on time. Okay, so for this project, okay, we are still working on the accuracy wise, because because this one actually the customer requires a very high accuracy. Case we have about 90 something, but to them it's still not sufficient, because this involve money. You see, when you want to keep some materials as inventory, it involves money. You see, but when so they want to have a very high accuracy in order to implement the model. Okay, so yeah, we are still fine tuning the thing, okay, the model, and hopefully you can achieve it soon. Okay, so these are the projects that I would like to share with you. Okay, so in case you have a text data, okay, on your hand, then you might want to do some text analytics. Okay, if you have some tabular data set, then you might want to, do some simple prediction. Okay, or maybe you want to identify what is the key influencer. Okay, what is the factor that actually affect, cause this thing. And if let's say you have some images, you have some image, then yeah, you might want to do some image analytics, okay, which means you implement deep learning, okay, which you will learn later, okay, to do some image analytics, okay, so that you can get some insights, okay, from the data set that you have on your hand, okay. So far, you have any questions that you want to ask before we proceed to the intro of commonality analysis? Any questions from the floor?
To us regarding the HR resume just now. So the
Yep.
data is considered as text analytics, is it?
Yep. For the resume, they are text data, so we use natural language processing, okay, which is part of the text analytics. Yeah.
Okay.
You will also learn this maybe in your don't know how which module which is your text module lah. You have one NLP module, your text analytics module. So yeah, you will learn about the processing of text during that time. Deep learning as well. So actually, for this program that you join, actually is it's a very good or very extensive program because it contains all the main component or the element of data science. You see, so for example, if you look at the first example that I share with you, which is on the resume, you see we have a back end. Okay, the back end, which you will also learn this in your one of your module, the big data technologies or something. Okay, so you will learn how to build your back-end infra to support your experiment. Okay, then I mean, you can do machine learning, deep learning based on the data set that you have, or text, you see, text analytics. Okay, based on the data that you have, you use suitable techniques. You apply suitable techniques, and then you visualize it to be implement, okay, or to be introduced to your customer. So of course, when you want to introduce it to your customer, you cannot just give the code, something like that, the Python code in the Jupyter notebook. Okay, so it is not proper. So you learn in this program, you also learn visualization, okay, where you learn how to put things into dashboard and to present it to your audience, okay, or to your customer, you see. So actually it's an end-to-end process where you learn from A to Z, okay, to form a data science project. Okay. So that's it about the sharing. Okay, if there's no more questions, then we will proceed further. Okay, to the intro for stats and also commonality analysis. Okay, so why you might want to ask, okay, why do you need to learn stats? You see, because you are in the data science module, so why stats? Okay, so for your information, okay, the data science actually consists of the main three main module, okay, which is computer science knowledge, maths and stat knowledge, and also the domain and business knowledge. You see, so in order to achieve this data science, okay, so all of you are the subject matter expert in your own field. Okay, so if let's say you are from healthcare, then you are the subject matter expert in healthcare. Okay, if let's say you are from physics, then you are the subject matter expert in physics. Okay, if you're from maths, then you are the subject matter expert in maths. Okay, so you are from industry, then you are the subject matter expert in your own field. Okay, so you already have this domain knowledge. Okay, you are already the subject matter expert in your own field. Okay, so for this program, we are going to introduce you the computer science knowledge and also the maths and stats knowledge. Okay, because you will need these two in order to achieve data science, especially for machine learning. Okay, so um, part by part, okay, about the technical skill, the coding, everything, computer science skills you will pick up. Okay, and also for the maths and stats, you will need stats to proceed. The basic or the foundation of machine learning or deep learning is actually from stats. Okay, or maybe the beginning of the experiment, you will start with statistics first, okay, then only you proceed further. You do EDA, exploratory data analysis, then only you proceed to CDA, confirmatory data analysis. Okay, so yeah, that's why today you are here to learn about the stats, okay, for data science. All right, so this is a virtuous cycle for statistics. Okay, so you have a process over here. You identify a process. Okay, you identify a process that you want to improve. Okay, then you identify the data. So when you talk about data analysis, data analytics, the first thing you think about is the data. So you need to know what is the data that you have in your hand or you're going to collect. You see, so you collect all the data, you get all the data, and you proceed to do the statistical test. Okay, the statistical methods, you do statistical tests, and from the statistical test, you will get useful information. Okay, you will get useful information, you get some insights from there, and what is the decision that you do? Okay, you will do a decision and you will have actions. Okay, and you lead to the process improvement. So the process improve, and you bring the process back to normal. Okay, so this is the virtuous cycle where you identify a process that you want to improve, you collect the data, you analyze them, and you make decision and you improve the process. Okay, so these are the main component that you're going to learn in this module. Okay, so I'm going to introduce you this commonality analysis method. Okay, so this commonality analysis method is actually a very widely used research method, okay, in many multinational company. Okay, so they use this CA commonality analysis method to do a lots of important decision. Okay, so under this commonality analysis, we have two main module, okay, which is the exploratory data analysis, the EDA, and also the confirmatory data analysis, the CDA. Okay, the EDA and also the CDA. So under the EDA, okay, we have descriptive statistic. Okay, usually we use graph. Okay, so what is EDA and CDA? Okay, so EDA is for you to get to know your data. Okay, for example, you get a set of data from your customer, from your clients. So you might want to understand the data. Okay, whether there's any outliers, any missing value, what is the relationship between the features, etc., etc. Okay, so you get to know your data. Okay, then you proceed to CDA. Okay, so CDA actually is driven by EDA. Okay, so it's driven. So after you do EDA, we will proceed with the CDA. Okay, so we use inferential statistics to proceed for CDA. And for this, we have a different statistical techniques that we can use. Okay, where you will learn all this component in this module. Okay, the stats for data science. Okay, what are the techniques that you can use to do CDA? Okay, so we have the two main component of commonality analysis, which is the exploratory data analysis and the confirmatory data analysis, the EDA and also the CDA. Okay, so I think I proceed a little bit more. Okay, before we proceed um to the what do you call it, the break, yeah. Okay, because yeah, I think it's still early. Okay, so let's proceed further. Okay, so far, if you have any questions, you can let me know, yeah? Okay, please let me know if you have any questions. Okay, so if you have no questions, then I will proceed to the introduction on commonality analysis. Okay, so I would like to share with you two uh, case study, okay, two case study, and we see what is the lesson learned from this case study. Okay, so the first one is about the Space Shuttle Challenger. Okay, so I'm not sure if you're aware of this incident. Okay, so this incident actually happened in year 1986. Okay, so in this year, okay, the NASA they actually launched their 24th rocket, the 25th rocket. So before this, they have launched 24 rocket. So now they want to launch the 25th rocket. Okay, so this is the structure of a rocket. Okay, so as you know, rocket it consists of a few parts. You see, so each part they actually concave them. Okay, they concave them by using this rubber O-ring. Okay, so we have rubber O-ring over here. So they concave them based on the rubber O-ring. So the function of the rubber O-ring is actually very important for them. Okay, the function of rubber O-ring play an important role. Okay, if there's any any spoiling or any arrows happens on the rubber O-ring, okay, any damage on the rubber O-ring, then it will lead to the explosion of the rocket. Okay, so it's a very serious issues. If let's say there's a malfunctioning on the rubber O-ring. So before they launch the rocket, okay, they will perform the weather forecast. Okay, the weather forecast. So they will forecast the weather, okay, for the next day. So tomorrow I'm going to launch the rocket. Today I'm doing the forecast to predict or to forecast the temperature for the next day to see whether it is suitable or not to launch the rocket. Okay, so they so for this case, for the 25th launch, okay, they actually perform the weather forecast, and the forecast temperature is actually 26 to 29 Fahrenheit, which means it's very, very cold weather, okay, on the next day. Okay, 0 degrees Celsius equals to 32 Fahrenheit. So it's below 0 degrees Celsius, you see. So it's very, very cold. So because of this results, okay, the engineer named Morton Tyoko, okay, Morton Tyoko actually have a concern on this launching. So he think that we shouldn't launch the rocket, okay, because of the cold temperature. He think that the cold temperature will cause the damage on the rubber O-ring. So he think that it's not suitable lah, to launch the rocket. So what he did is he faxed data to the NASA officer to ask them to stop the launching. So these are the data set that they faxed to the NASA officer. We look at this one, the bigger one. Okay, so before this, this is the 25th launch, right? So the 24 launch, okay, of the rocket is seven launch, yeah, seven of the launching out of the 24 launch actually consists of a little damage on the rubber O-ring. Not much, just a minor damage. Okay, so they record now the temperature, okay, when they launch the rocket, the forecast temperature. Okay, so these are the seven damage that they have. Okay, and these are the forecast temperature. So maybe it's a bit difficult to visualize. We plot into charts, yeah. We plot into graph, and you can see from here, you see, when the temperature is 50 to 55, okay, 50 something, there is a damage on the rubber O-ring, okay, but not that serious damage. So the launching is still smooth. Okay, but just they notice about some damage on the rubber O-ring. Okay, so second, this 55 to 60, there are also some damage. Okay, so these are the temperature. So these are the damage that they plot. Okay, so out of the 24 launch, okay, actually 7 launch have a minor damage on the rubber O-ring. So these are the results. Okay, so they fax this data to the NASA officer to ask them not to launch the rocket. So based on this, based on this data, okay, NASA officer actually decide to launch the rocket without considering the advice from Morton Tyoko. You see? Why? Okay, because from here, okay, the forecast temperature is 26 to 29 Fahrenheit, yeah, which is a very, very cold temperature. But based on the previous damage on the rubber O-ring, okay, NASA officer claimed that there is no evidence saying that cold weather will cause this damage on the rubber O-ring. Okay, you see, 50 something that is also a damage one. You see, 70 something that is also a damage on the rubber O-ring. 60 something there is also a damage on the rubber O-ring, but there is no evidence saying that 20 something over here that is a damage on the rubber O-ring. You see, so the NASA officer think that there is no evidence saying that cold weather will cause the damage on the rubber O-ring. So they launched the rocket, okay, as planned, okay, without considering the advice from Morton Tyoko. Okay, so this is what happened the next day when they launched the rocket. So after they launched the rocket, actually the rocket exploded, okay, after 73 seconds into flight. And because of this poor data analysis, 7 astronauts died because of the rubber O-ring leakage. Okay, so there's a very serious leakage on the rubber O-ring. The rocket explode, and then 7 astronauts die because of this. So what is the lesson learned from this set incidents? Okay, what is the lesson learned? So this is the first data set that Morton Tioco faxed to the NASA officer, you see, and they plot the charts saying that okay, you know, that there's no evidence saying that there will be a damage on the rubber O-ring when the weather is cold, you see. So these are the 24 launch, okay, successful launch. Yeah? They have launched 24 rocket before and they mark down all the damage, okay, the minor damage on the rubber O-ring. Okay, and also they record down the temperature. So now they include all sets, I mean the full set of data. Okay, the full set of data. So over here, okay, the green color one are the good launch, which means there is no damage on the rubber O-ring. Okay, while the red color one, okay, the red color ones are those launch with a minor damage on the rubber O-ring. Okay, so you can see from here. So now we can see clearly all the good launch actually happen when the temperature is above 65 Fahrenheit. Okay, it's above 65 Fahrenheit. So when the temperature is above 65 Fahrenheit, you can see that we have good launch. But all those launch below 65 Fahrenheit will have some minor damage on the rubber O-ring. You see? So if let's say we look at this data earlier, then they will not launch the rocket because the good launch only will happen when the temperature is above 65, which means a cold weather will lead to the damage on the rubber O-ring. So now we have the proof already. You see? So what is the lesson learned from these incidents? Okay, so when we do data analysis, okay, when we do data analysis, remember to include both the good and the bad sample. Okay, we are looking at those damaged rubber O-ring, but we cannot look at only the damaged data set, you see. You also need to look at those good launch, which is the green color one. Because the green color one, the good sample, will act as the benchmark or the guideline for your data analysis. Okay, so with this green color one, then we can see clearly, oh, the good launch actually happened when the temperature is above 65 Fahrenheit. So we shouldn't launch the rocket at that moment. You see, so because of the poor data analysis, so we sacrificed 7 astronauts. Okay, because of this. Okay, so remember, okay, when you do data analysis or do data analytics, okay, remember to include both the good and the bad sample. Okay, says you want to predict the survival rate of the cancer patient, you cannot only look at the die case, you also need to look at the survive case because the survive case will act as the benchmark, okay, for your data analytics. You see, so you have to include both the good and the bad sample. Okay, then only you can have a very accurate data analysis or data analytics. Okay, so this is the first um, case study that I would like to share with you. Okay, and we have the second one, which is the real world example. Okay, this is the real data set that is really happened. Okay, so you can see from here, okay, we have a line, okay, a manufacturing line, okay, where you have this Fab 12. Okay, in the Fab 12, this plant, okay, so we have two epoxy link. We have epoxy link number 1 and we have epoxy link number 2. Okay, and they noticed that there are 10 bad lots actually being produced by this Fab 12. You see, so they want to know, okay, whether they should check epoxy link number 1 or they should check epoxy link number 2. So what is the root cause that actually caused this bad lot? So which one that they should check? They should check epoxy link number 1 or they should check epoxy link number 2. Okay, what is the root cause? Okay, that actually caused this bad lot. Okay, so you might want to ask, okay, the popular question from the floor is, why not I just ask the engineer to check both epoxy link? I check epoxy link number 1, I check epoxy link number 2, then I know what is the problem, which one has the problem, is it? So for real world example, real world scenarios, okay, for the manufacturing industry, for them, time is money. Okay, when you involve something about cost, then yeah, I mean it will it's not that easy to deal with, you see. So what they want is a fast decision, okay, and low cost. Okay, so if you want to check both epoxy link number one and epoxy link number two, we can, but you need more people. You need more people to check both epoxy link, and it is time consuming, right? Because you need more time. You need more time to investigate both epoxy link. Then time is money. So when you involve more time, then you lost more. Okay, lot more costs were incurred. Okay, so this is not good for them. To them, it's not good because what they want is the speed and they want low cost. Okay, so the best thing is you do a data analysis, a good data analysis, then you find out the root cause and the engineer can go straight to the point to solve the problem. Okay, so they want to do a data analysis to find out what actually causes bad lots. Okay, so the first set of data analysis they do, okay, you have 10 lots and 5 bad lot from epoxy link number 1. 5 bad lot is produced by epoxy link number 2. You see, you have 2 bad lot. You have 10 bad lot, 5 from epoxy link number 1, 5 from epoxy link number 2. So meaning to say 50-50, okay, 50-50. So when the engineer asks you, if let's say you are the statistician and the engineer asks you, so which epoxy link that we should check? Epoxy link number 1 or epoxy link number 2? And you have no answer for that because you have to do a poor data analysis, you see? 50-50, so there's no answer for that. Which one? 50 from epoxy link number 1 and 50 from epoxy link number 2. So they will still need to check both, you see? So this is not a good data analysis because they don't include the good lots. You see, they only look at the bad lot. Okay, so a good data analysis, you should consider all the lots, which include the good and the bad sample. For example, this one, Fat 12, in total, you have 50 lots. Okay, you have 50 lots, and actually 45 lots go through epoxy link number 1 and 5 lots go through epoxy link number 2. You see? So out of these 45 lots processed by epoxy link number 1, 5 of them are bad. Okay? So these 5 lots processed by epoxy link number 2, 5 of them, all of them are bad lot. You see? So now it's very clear. You see? It's very clear to see who is actually the root cause. Epoxy link number 2 is actually the root cause. Okay? So all the lots produced or go through epoxy link number 2 are bad lots. Okay, so you have 100% bad lot. So the engineer should go straight to the point to investigate epoxy link number 2. What actually goes wrong for this epoxy link number 2? Okay, so you see, from here we know that, okay, we need to include, okay, the lesson learned from here is we need to include the good and the bad lot for the data analysis, you see. If you don't include it, you look at only the bad data set or the good data set, then you will get a wrong decision or a wrong conclusion. Okay, for example, this case 50-50. Okay, but if you look at the overall, okay, epoxy link number 1 only produced 11% of the bad lot, while all the lots produced by epoxy link number 2 are bad lot. So the engineer should go straight to the point to investigate epoxy link number 2 instead of epoxy link number 1. Okay, so this is the lesson learned. Okay, when you want to do data analysis or data analytics, make sure that you include both good and the bad lot, because the good lot will act as the benchmark or a guideline, okay, for your data analysis or your data analytics. Okay, so far you have any questions that you want to ask at this point before we proceed to a quick break? Any questions that you want to ask? No questions. Okay, so I hope all good, yeah? All right, so if no questions, then we should go for a quick break and we will come back, okay, after 20 minutes, yeah? So I will see you after 20 minutes. Thank you. Okay, hello everyone. Welcome back. Oops, I see some message. Yeah, can you hear me, right? Things should be good now. All right. Okay, thanks for your response. All right, thank you. So, I think we are good to proceed further. Okay, so we will proceed to the introduction on the commonality analysis. Okay, so this is the definition on the commonality analysis. Okay, so commonality is actually the characteristic of the bad lot. Yeah, it's not the characteristic of the good lot. Okay, so commonality signal actually happen because of something. Okay, so there must be something that cause this signal, commonality signal. So we have to use commonality analysis to find out the root cause. Okay, what actually caused this problem? Okay, what actually caused the problem? Then we solve the problem and we bring the process back to normal. Okay, so this we call as a commonality analysis. Okay, we want to find out the root cause. Okay, so commonality analysis has actually been widely used in many multinational company. Okay, to do a very important decision. You see, so that's why for this module, okay, we will heavily learn okay about this commonality analysis. Okay. So commonality analysis can be used to answer all these questions like why this happened, why the yield drop, why the resistance degrade and stuff. So why the temperature fall. So all these can be answered by using a proper commonality analysis. Okay, so commonality, this is the commonality analysis goal. Okay, so immediate goal of commonality analysis is to find the commonality signal. So when something happen, okay, you might need to catch the signal. So what actually caused the thing? Okay, what actually caused the signal? Okay, and how it looks like. So the immediate goal for this commonality analysis is to catch the signal, to find the commonality signal. And the interim goal is to implement the effective containment action. So what is containment action? Okay, so containment action is actually, for example, if let's say you have a process, okay, if let's say you have process, so we let's say we do quality control, quality checking, okay, on the process. So we'll measure the maybe the diameter of some product, and suddenly you notice that there's a signal, okay, it's go out of control. Okay, maybe the range is about 5 mm, but suddenly it go out to 5 point something, 6, it getting worse, you see. So interim goal of the commonality analysis is to implement the containment action, which means you hold it first. Okay, think of some methods to hold it. Don't let it get worse. Yeah, it is already out of control, but I mean the signal is out of control, but you have to think of a way, uh, implement a containment action. Don't let it get worse. You keep it you in control. Let's say 5.5. You keep it in 5.5, and immediately you perform the commonality analysis, which is the ultimate goal is to find out the root cause. Okay, what actually caused this thing happen? Okay, what actually caused this thing happen? And you find out the root cause and you bring the process back to normal. Okay, so this is the commonality analysis. It is about the commonality analysis. The immediate goal is to find out the signal. Interim goal is to implement a containment action. Hold it, don't let it get worse. Okay, and ultimate goal is to find out the root cause. What actually caused this happen? Solve the issue, solve the problem, and bring the process back to normal. Okay, so for commonality analysis is a sequential nature, which means um, it is not the same or it is different with the um, machine learning or the data analytics that you have learned before. Okay, so usually for if you do data analytics, okay, you will collect the data set, make sure that you got a good data set, a good set of data, sufficient amount, and then only you start to do the experiment, right? Because you have learned about the machine learning. So I suppose you already know this. Okay. But for commonality analysis is a sequential nature. So which mean you don't have to have a very perfect data set at the first place. Okay. So what we talk about commonality is about speed. Okay, it's about speed. So time is money. They want to solve things as soon as possible. Okay, so for commonality analysis, you just use whatever data that you have in your hand first. Okay, so it's okay to start with a very, very small set of data. Okay, it's not a perfect data set, it's fine. Okay, for commonality analysis, we use whatever that we have in our hand first. We proceed to the experiment, and if we get the insight, then we will stop. Okay, we will proceed to the decision. Okay, if not, then we will back to the first place, collect more data, and then do more experiment and see whether we got insight or not. If yes, we stop. If not, then we go back, collect more data, etc., etc. Okay, so this means sequential. This is the meaning of the sequential nature, where you don't have a proper or maybe a perfect data set, okay, to start with. Okay, says for example, this case, you detect a signal. Okay, so immediately you collect the data. So you collect whatever data that you have in your hand first. No need to dig all the historical data or whatever. Just use whatever data that you have in your hand first. Okay, of course you need to extract them out. Then you conduct the commonality analysis. Okay, so you interpret whether you after you conduct the analysis, you will get so many values, so many numbers. So you interpret it. Okay, what is the meaning of this? What is the meaning of that, etc. Then you determine whether this is a useful signal or not. If yes, then you will proceed. Okay, you will proceed to the decision. Okay, the improvement. If no, then you go back to collect more data. Okay, then you collect more data and you go through the same step, and then you ask yourself whether you have satisfied with the result, any insights being found. If yes, proceed to the improvement. If no, go back again. Okay, so this is the flow of the commonality analysis. So this is a quick intro lah on Python, Anaconda, Jupyter Notebook, but I mean, I'm not going to go through this very detailed because you have learned in the first two module. Okay, so in this module, okay, I'm going to use Python because as I already mentioned about uh, the fact just now, which is I encourage you to learn because you can do a end-to-end, experiment framework, okay, in Python alone, meaning one tools only without doing the EDA in Jump, then you extract out the result and then you put it into Python. So it's like a two-time job, you see. So it would be good if let's say you know, uh, start, if let's say you want to do data analytics, so your data analysis, you start from Python as well. Okay, and also it's free, it's an open source, and very interactive. It's a great interactive environment, meaning it's very easy to be integrate to any tools. Like the project that we did before, the resume mining. We can easily integrate this Python with Hadoop, and then you can easily integrate with Tableau, Power BI, all those. So it's very easy to be integrate with other tools. You see, so that's why I would like to recommend you this Python for to do sets. And Anaconda wise, you have installed it, so you have find it very easy to use, right? Because you don't need to install one by one. If you go without Anaconda, you will need to install NumPy, wait, install SciPy, you wait, you install Matplotlib, then you wait, then only you can use all of them. You see? But if let's say you install Anaconda itself, then all this package has been installed. Okay, it has already pre-installed, so you can just proceed. Okay. So yeah, from here you can launch your Jupyter Notebook. So Jupyter Notebook again, we would like to recommend this to you is because Jupyter Notebook very user friendly. You have used it. I believe you love it because it's easy for you to store all this coding, rerun and rerun, do the experiment. Actually, it's a very helpful and very useful interface. Without this Jupyter Notebook, you might want to code in a very in a command prompt. You see, all the machine you have your command prompt. So a black color command prompt actually is not user friendly at all. Okay, especially for if let's say it's not, I mean, it's for beginner for the programming. Okay, then it is not user friendly. So that's why we introduce you this Jupyter Notebook as one package, the Anaconda, Python, and Jupyter Notebook. Okay. So far, if any questions that you want to ask before we proceed to a game, okay, if you have any questions.
I have a question, Doctor.
Yep.
Uh, During the commonality analysis, does it involve any validation process or any validation analysis?
No, this is not a prediction. Actually, is to find out the root cause only. So you're not going to have any evaluation process for this. Yeah,
I
but
mean,
it's
any
data
any
analysis.
validation?
Nope. So the engineer will need to investigate lah. What is, if let's say is they find out the root cause, then the engineer will need to go and revert. I mean, to investigate. Okay, why actually this happened, etc. So the following process will be, yeah, to the expert lah, the subject matter expert. Yep. So we are not going to validate at our side, but we will do different set of experiment. For example, you do EDA, you do CDA, and then CDA you have different techniques. Okay, so you can compare all these technique whether they have the same conclusion or the same insights or not. So from there, roughly we can estimate how accurate is it. So usually your EDA result, the exploratory data analysis result, will be the similar one with your confirmatory data analysis results. So if let's say that's the case, then consider it's quite accurate already. So we will proceed to yeah, the decision. I mean to investigate lah, the root cause.
Okay, understand. Thank you, Doctor.
Okay, thank you. Any more questions from the floor? All right. So if no questions, then please go to your quizzes. You might want to. Eh, there's another question. Is it? Can we make web programming using Jupyter? Actually, Spider better. If let's say you want to do web programming, Spider, it's also in Jupyter. Your Anaconda, you launch Spider. Spider better. Because Jupyter Notebook more to beginner, and then yeah, it's more user friendly to the beginner. But if let's say you want to go for implementation wise, etc. So or maybe like you mentioned web programming, so Spider would be much more suitable, yeah, compared to Jupyter. All right. Any more questions that you want to ask? Welcome. All right. So if no, then let me launch the game. We play a quick game. Right. So wait for a while. Yeah. You can go to quizzes. Then wait. Yeah. We put in the code. Let me share the screen. Okay. You can start to join the session. Yeah. Let me open my chat. Okay. I think I will launch the game. Right. All the best. Enjoy. Okay, so this is not Java distribution, yeah, it's a Python distribution, right? Okay, we have the last questions. Right, so let's see who is the champion for today. Okay, I'm going to launch the leaderboard. All right, so we would like to congrats our for the day. So we have for our champion for today, 90, and we have the first runner plus one, and also second runner Una. Okay, congratulations for our winners for the day. All right, so I hope you enjoy the game. All right, let me close the game first. Let me sharing. Oops, I forgot to share the audio just now. It's like I'm playing the game without audio. Sorry for that. All right. So later I will post this leaderboard to our e-learning portal. All right. So in the meantime, okay, so let us continue on our lecture for the day. Okay, let me move this up. Yeah. All right. Okay. So after you play the game, so now you should know better. Okay, I hope you know better for the about what we have learned. Okay, in the first half. Okay, so moving forward, we are going to explore about this EDA, exploratory data analysis. Okay, so we have done the first part. So second part EDA. Okay, we were going to learn about the descriptive statistics, the measure of central tendency, variables, and also the visualization by Python. Okay, so okay, so this is just a quick recap, yeah. Okay, a quick recap, okay, for the basic of stats. Okay, but you need to know. Okay, you need to. I need to refresh you about all these statistical terms before we can proceed further. Okay, to the hands-on, to the experiment later, because you're going to use all this term later. Okay, so just I will go a bit fast. Okay, for this part. Okay, because I think you all are already very well versed on this. Okay, just revisit on that. Okay, so first, types of variable. Okay, we have two main types of variable. We have qualitative and quantitative variable. Okay, so qualitative variables. Okay, qualitative variables are variables that not involves numbers. For example, gender, marital status, eye colors, the state of birth, etc. Okay, quantitative variables, okay, are those variables that involve numbers. For example, your height, your weight, your salary, number of children you have, the time, all those involve numbers. The one we call it as a quantitative variable. Okay, so under quantitative variable, we have discrete and continuous. Okay, so discrete variables, so in short, yeah, in layman term, okay, discrete variables are whole number. Okay, whole number. You cannot split it into decimal places. Okay, for example, your fab plant, fab lot, your machine, your epoxy link. Okay, it has to be a whole number. For example, number of children, number of TV, number of books. You only have 1, 2, 3, 4, 5. You cannot have 1.5 books or 1.5 pencil, 1.5 TV. Okay, so the one that belongs to discrete variable. Okay, while for continuous variable, it can be any numbers. For example, your height, your weight, your salary. Okay, it can be 1.1, 2.2, 2.3, 4.4. It can be any numbers. Okay, so discrete is a whole number. Continuous variable, it can be any numbers, any values. Okay, so summary of the variables. Okay, we have qualitative variable and we have quantitative variable. Okay, qualitative variables are not numbers. For example, color, marital status, your gender, that's not numbers. Okay, quantitative variables are numbers. Okay, and we have discrete and continuous. Discrete variables are whole number where you cannot split into decimal places. Continuous variable, it can be any numbers. Okay, so this is the summary of the types of variables. Okay, and you have the four level of measurement. Okay, level of measurements. We have nominal, interval, ordinal, and ratio. So what does it mean by this nominal, interval, ordinal, and ratio? Okay, we look into this. For nominal variable, okay, nominal variables are not numbers. Okay, for example, male, female, and then your eye colors, your green, red, orange, blue. Okay, type of house, type of pet you have, your genotypes, all these non-numbers. Okay, we call it as a nominal variable. It's like the name, lah, okay, and the name of the variable. Okay, While ordinal variable, they are also not numbers, okay, but there is a ranking. Okay, there's a ranking. For example, how do you feel today? Very unhappy, unhappy, okay, happy, very happy. Okay, so there's a rank. Okay, first, second, third, fourth, fifth. Very unsatisfied, someone unsatisfied, neutral, someone satisfied, very satisfied. So this one, you have ranking one, we call it as an ordinal variable. Okay, so this one later when you use jump, then you will always see all this term. Okay, so that's why I would like to introduce this to you first. Okay, ordinal variable. And we have interval and ratio. Okay, so the both this interval and ratio, they are numbers. Okay, they are numbers. Okay, but the only different, the main difference, okay, of interval and ratio is ratio 0 on the scale means does not exist. Okay, so when you have 0, okay, when you have 0 for your for this ratio, when you have 0, it means does not exist. When you have 0 weight height, meaning you don't have, the weight height. Sales 0, you don't have sales. Income 0 meaning you don't have income. Number of children 0 meaning you don't have children. Okay, so 0 means does not exist. While for interval, the interval, it means something. Okay, 0, it means something. For example, 0 degrees Celsius, okay, it means a very cold temperature. Okay, a freezing point. Okay, 0 degrees Fahrenheit, it means something as well. 0 IQ, okay, low IQ. 0 for the time, meaning it's a 0 at the midnight. You see? So 0 means something for interval, while 0 means does not exist for ratio. Okay, so you have interval and ratio. Okay, so that is about the level of measurements and the variable. If you have any question, can let me know, yeah? If not, then I will proceed to the descriptive statistics. Okay, so before we go further, you will need to know what is the meaning of population and sample. Okay, so population is your research population. Okay, your research interest. Okay, for example, I want to know the happiness index of USM. Okay, of USM. So what is the happiness index of USM? So my interest or my population is USM community. Okay, so USM is my population. Okay, USM is my population. All right. So so of course I cannot get everyone in USM to participate in my research. You see, there's so many people in USM. You have students, you have lecturers, you have staff, you have visitors, you have guests, so many people in USM. So we cannot ask everyone, what is your happiness index? What is your happiness index? And then you get the mean of the happiness index, right? So it's impossible for us to ask everyone in the population to participate in our research. So we do sampling, we select some sample. Okay, we select some sample and we ask these 5 people, okay, what is your happiness index? What is your happiness index? What is your happiness index? So you get the mean of the sample. You add up the happiness index, divide by 5. So we will assume that the happiness index of the sample will represent the population. Okay, will represent the population. Right, so this is the meaning of the population and the sample. This one, you will be heavily using this principle when you do the statistical analysis later. Okay, so population and sample. So we proceed to the measure of central tendency. Okay, measure of central tendency, the most commonly used one, yeah, is your mean mode and median. Okay, is your mean mode and median. Okay, so when you talk about measure of central tendency, is mean mode and median. Okay, the commonly used one. All right, so this is the equation for the mean calculation, but no need to, I mean, just for information, no need to memorize. Okay, so how do we calculate the mean? Okay, so just a quick example. Okay, we will add up all these elements that we have in our sample. Okay, you add everything up. Okay, and you divide by the number of entries that you have. Okay, for example, you have 1, 2, 3, 4, 5, 6, 7. You have 7 entry. Okay, so you add up all those 7 and 3 and you divide by 7. Okay, so it will become your mean. Okay, this one is just a quick refreshing, yeah? All right, so median. Okay, how do we calculate median? Okay, so let's say we want to find the median for this one. Okay, we have 1, 2, 3, 4, 5, 6, 7. Okay, so you arrange the data from the smallest to the biggest. Okay, from the smallest to the biggest, and you get the center or the median entries. So these will be your median. Okay, so 3, 3. So this one is the middle element, the middle entry. So this is your median. Okay, so your median weight is 268. All right. So if let's say you have, so this one is if you have an odd number, yeah, you have 7. You see 7 and 3. So of course you can get your middle punya data entries. Okay. What if you have even number? You see, if you have an even number, you have 1, 2, 3, 4, 5, 6. You have even number, so how? Okay, how do you get the median? There's no median entry over here. Okay, so in this case, we are going to again order the data from the smallest to the largest. Okay, then you get the average of the middle two middle entry. Okay, which means this 2. Okay, so you have 235 plus 268 divide by 2. Okay, so you get your median over here, 251.5. Okay, so if you have even number, then you need to get the average of the central elements. All right, so this is about your median. And finally, about your mode. Okay, your mode is the one that have a greatest frequency. For example, in this data set, okay, you have 2, 2, 3, 5, and 3. 2, 3, 5, 2, 3, 5 appear twice, you see, and others only appear once. Okay, so this means that your mode is 2, 3, 5. Okay, because it appeared twice. Okay, so mode is the one that appear the most, okay, in your data set. So you have, so this is how you calculate your mean, mode, and your median. All right. So what do we want to, what is the purpose for us, to learn about this mean, mode, median? All right. So usually we will use this min mode median to represent our data set. Okay, to represent our data set. The most commonly used one is the mean. Okay, usually we will use the mean to represent our data set. Okay, we will use the mean to represent our, if you have one set of data, usually we will use mean to represent that data set. But the downside of the mean is it will affect by the outliers. You see, because you add up every entries, you divide by the number of entries that you have. You see, so it will be, the mean will be affected. Okay, it will be affected by the outliers. If there's an outliers here in your data set, then usually we don't use the mean to represent your data set. For example, okay, if you have a data set like this, okay, so which measure of central tendency best describe this data set? Okay, so from here you can see that it's all about 20 something, but then you have 165. You see? So 65 is actually our outliers. Okay, it's actually our outliers. So we calculate the mean mode median. The mean is we add up everything, divide by 20 entries, so you get your mean. Okay, but the mean is affected by this 65, you see? All right, median. Okay, you arrange everything and you get the middle average. Okay, the average of the middle entry. So you get 21.5. While mode here is 20 because 20 appears the most okay, in the data set. Okay, so you have mean, median, and mode. All right. So from here, which one is the best to represent our data set? Okay, for this case, most of the case we will use mean and mean to represent our data set. Okay, but for this case, because we have one outlier, so we will use median to represent our data set. So certain we will select median. Median also take into account every um, entries, every element in the data set. You see? So um, because we also consider, this, and then we take the central entry. So median usually is the second choice. Okay, if mean is not suitable, then we will use median. Okay, and lastly, finally, only we will choose mode. Usually we won't use mode, lah. Okay, but we will use median or mean. Okay, based on the suitability. Okay, so from here you can see that there's outliers over here. Okay, so definitely mean is not good okay, to represent, or not suitable to represent the data set already. So we will use median. Okay, for this case. So this is the shape of the distribution. Okay, when you have a distribution, okay, you have a few types of distribution. This is the symmetry distribution. You have mean, mode, median. You see? So mean, mode, median over here. If your mean value is the same with your median, is the same with your mode, then your distribution is a symmetry distribution. Okay, if you have a distribution like this, your mean is equals to your median, then it is called a uniform distribution, which is a rectangular distribution, a symmetry distribution. Okay, so if your mean, okay, is to the left of your median, okay, your mean is at the left hand side of your median, then the distribution skew to the left. Okay, it's negatively skewed to the left. All right. While when your mean here is on the right of the median, so it means your distribution skew to the right. Okay, so you have skew to the left and skew to the right distribution. Okay, if your mean is at the left hand side of your median, then skew to the left. Okay, if your mean is at the right hand side of your median, then skew to the right. Okay, so that is about the measure of central tendency. Okay, measure of central tendency. Now we go into the measures of variation. Okay, the measure of variation. So in order to calculate the measure of variation, okay, you will need to know about this range. Okay, I believe you already used to it, but just a revisit, yeah? Okay, so range is the maximum value minus the minimum value. For example, okay, if you have a data set over here, you want to know the range of the starting salary for the first company, company A. Okay, so you will get the minimum value and the maximum value, and you use your maximum salary minus your minimum salary, you will get your range. So your range is 10, meaning to say the range of the starting salary for company A is actually 10, which is 10K. Okay, so this is the range. Yeah. Okay, so you might want to ask, why do we need to learn this variation? Okay, you learn about the measure of central tendency. Why do we want to learn about this variation? So what is it? Okay, so when you have the same measure of central tendency, okay, for example, you have the same value, you have two set of data. Okay, you have a two set of data, and the two set of data punya mean, median, and the mode, they are the same. They have the same mean, which is 41.5. They have the same median, which is 41. They have the same mode, which is 41, but they actually they are differ significantly. Okay, they are differ significantly. So what does it mean by differ significantly? Okay, what does it mean by differ significantly? All right, so for this case, okay, differ significantly. So what does it mean? All right, so um, you have the same measure of central tendency. It doesn't mean that you have the same variation as well. You see, for example, the data set that you have just now, this one, you have the starting salary for company A and the starting salary for company B. You see, you have two set of data. The two set of data, they have the same value of the center of tendency. You have the same mean, same median, and same mode. But they are different, they are differ significantly because you can see from here, you see, the distribution, okay, are very different. For company B, okay, it is widely spread, you see. Widely spread, it means you have a high variation. Okay, where for company A, okay, it's a low variation, it means okay, it is not widely spread. Okay, not widespread. So this is the difference. They have the same value of mean, mode, median, but they are differ significantly. Okay, so because they have the different variation. Okay, so in order to calculate your standard deviation or your variance, you will need to know what is the deviation. Okay, what is the deviation? So deviation is the value, okay, your value minus your mean. Okay, so when you have an entry coming in, so you find the deviation, okay, the deviation between your median and also your entry. Okay, so let's say your mean is 5 and the entry is 3. Okay, the entry is 3. So 5 minus 3, you have 2. So the deviation is 2. Okay, the deviation is 2. So deviation is the difference between the entry and the mean. Okay, we call it as a deviation. So this is the equation for the variance and the standard deviation. Then no need to memorize, yeah, just for your information. All right. So what is the difference? Yeah, when you can see the distribution over here, you see. So this one, the flatter curve, or we can say the fatter curve over here under here. This one is actually it means you have a high variation. Okay, you have a high variation over here. You see, so this one you have a lower variation, meaning you have a low value of standard deviation or variance. Okay, so this is a high variation and this is the low variation. Okay, so this is the equation for your sample variance and your sample standard deviation. All right, but also no need to memorize, just for your information, because the tools will calculate this for you. Okay, but you need to know lah, okay, the back end, okay, the theory behind. Okay, so this is how you interpret your standard deviation. Okay, you can see from here, yeah. Okay, 5. Okay, you have all the entry 5 and your mean is 5, you see? Okay, so there's no deviation. Okay, you have the same value of entry. So your standard deviation is 0, meaning there is no deviation. Okay, no deviation. They are the same with the mean. You see? So over here, if let's say you have your mean is 5, okay, you have your mean is 5, and then you have um a bit of variation, you see? Your mean is 5 and your entry is like 4, 3, 6, 7, a bit of variation. You see, you have a small value of standard deviation, meaning to say you have a low variation. Okay, but for this case, okay, if you have a mean 5, but you have a high deviation, you see, the entry is 2, 3, and then 7, 8, which means it deviates a lot from the entry, from the mean. Okay, so it means that you have a higher value of your standard deviation. Okay, you have a higher value of your standard deviation. All right, so this is how you interpret your standard deviation. If you have a high value of standard deviation, it means the entry deviate a lot from your mean. Okay, it deviate a lot from your mean. So you can actually briefly estimate, okay, your standard deviation, but usually I mean the tools will help us to do so. But this is just maybe for your interpretation, okay, for the illustration purpose. Okay, for example, okay, if you have 8 entries, you see you have 8 entry and all of them are 4. You see all of them are 4. So it means that the standard deviation equals to 0. Okay, standard deviation equals to 0, meaning to say there is no deviation. Okay, there is no deviation, okay, from the mean. So 0. Okay. Secondly, okay, if your mean, okay, is 4, and you see your entry is 3 and 5. 3 meaning to say it is deviate from your mean for 1, right? 5 meaning to say it is deviate for your entry by 1 as well. So your deviation is around 1, you see? So your standard deviation will be 1. Okay, because the deviation is 1. It deviate from the mean by 1. Okay, next. Okay, if you have 8 entry and the mean is 4, you see? So over here, if the entry is 3, so it divide by 1. If the entry is 1, it divide by 3. Okay, same goes to 5. If the entry is 5, it divide from your mean by 1. If the entry is 7, it divide by your entry by 3. Right? 7 minus 4, 3. Okay? So your standard deviation will be around 1 plus 3 divided by 2 lah. Divide by 2, so it will be around 2. Okay, so your standard deviation will be around approximate 2. Okay, the exact one is 2.2. Okay, so it will be around 2 because the deviation is around 2. Okay, from the mean. Okay, so this is how you calculate or you understand the meaning of standard deviation. All right, so you have any questions that you want to ask before we proceed to the data visualization part? Okay, suppose all good because that is the basic, okay, that you have learned previously. Okay, okay, thank you for your response. All right, so it's just a quick revisit because just later we are going to use it. Okay, the term, all those terms, we are going to use them. All right, so now we look at the data visualization. Okay, data visualization in Python. Okay, so you have learned, I believe you have learned a few. Okay, you have learned a few data visualization techniques, or maybe you have already do some plottings in the first few module, maybe the two modules that you have learned before. Okay, but for stats, okay, these are the commonly used one. Okay, these are the commonly used graphs. Okay, for stats only. Okay, for stats. So let's look at what this is all about. Okay, first you have a histogram. Okay, I believe you have already familiar with histogram. Just a quick revisit, yeah. So this is how a histogram looks like. Okay, so you have histograms and you have a frequency polygon. Okay, so frequency polygon we derive from histogram. So you plot this, you can see over here, yeah. You plot the midpoint of each bar, okay, and you merge them up, you link them up over here, so it will become your frequency polygon. Frequency polygon is derived from your histogram. Okay, frequency polygon is derived from your histogram. So you might want to ask, so since the frequency polygon is derived from histogram, so why do I need to have frequency polygon and histogram? So when to use which? Okay, when to use which. So the main difference, okay, for histogram and frequency polygon is, okay, when you want to have a very detailed view, so you will need to use histogram. Okay, for example, you want to know how many elements that you have in this range, how many elements you have in this range and this blah blah blah. So histogram is much more suitable, okay, to you. While if let's say you have a few set of data, okay, you have a few set of data and you want to compare them side by side, then frequency polygon is much more suitable. Okay, it's much more suitable, but there's no detailed view for your frequency polygon. Okay, so you can see from here, let's say you want to compare, let's say the sales, okay, etc., etc. Then the frequency polygon is much more suitable, you see. But if let's say you want to have a detailed view, then histogram is much more suitable. Okay, so for this visualization, okay, the tools can help you to perform the plotting. Okay, the tools can help you to perform the calculation. But you yourself, as a data scientist or as a data analyst, you will need to select your own. I mean, you will need to make the decision. Okay, you will need to make the decision. You will need to make your own decision which graph or which chart that you're going to plot. Okay, if you have this kind of data set, so which graphics that I should plot, then the chart can help you to do the plotting. Oh, sorry, the tools can help you to do the plotting. But you yourself, as a data scientist or data analyst, you will need to do the decision. Okay, so our role is to select the suitable charts, suitable graph, and okay, the tools help us to plot the charts. And again, okay, the role fall back to the statistician or data scientist or data analyst, you will need to do the interpretation. Okay, you will need to decide if I have all these numbers, the tools can give you a lot of numbers, a lot of value. What does it mean? Okay, what does it mean? So uh, you will need to know how to interpret them. Okay, so that one is the knowledge that is needed for a data scientist or data analyst. So after you have all this value, so you will need to do the interpretation and also finally the conclusion. What is the conclusion that you can make from these insights? Okay, so you make the decision and then you proceed to the implementation. Okay, so next we will proceed with the box plot. Okay, so these are the 5 statistics that we need to plot a box plot. Okay, so this is the equation, and then for you to perform the calculation, and this is how it looks like. Okay, a box plot. Okay, 25% for each quartile. All right. So the good thing, okay, the good side for box plot is, okay, first, okay, you can easily see whether your data set is left skew or right skew. Okay, if your right hand side is greater than your left hand side, so it means your distribution is right skew. Okay, if your left hand side is greater than your right hand side, so it means your distribution, your data set is left skew. So it's very easy to view by using a box plot. Okay, second, if you plot a box plot, it's very easy for you to notice about the outliers. It's very easy for you to view, okay, if your data set contains any outliers or not, okay, by using a box plot. And then it's also very easy for you to compare side by side for few set of data. Okay, but for example, this case, you can easily compare their median, okay, by plotting a few box plot together, side by side. Okay. And also, it's very easily for you to view the spread of your data set, whether it is not widely spread or it is widely spread. You see, so it's very easy for you to view, okay, the spreading of your data set. Okay, so that is about the box plot. Okay, we have our box plot. And then we will go to the scattergram. The scattergram is the most widely used graphs for stats. Okay, so we will use scattergram when you have both continuous variable. For example, continuous variable, yeah, we have learned just now, both numbers. Okay, for example, height versus weight, age versus salary. You see, so both numbers, you will use scattergram. Okay, scattergram. All right, so this is some example for scattergram. Okay, age versus cost, salary versus height, height versus weight, age versus salary. You see, so these are a few samples. Okay, so when you have both continuous variable, so you will need to plot a scatter plot. All right, and the last one is the heat map. Okay, is the heat map. So heat map, okay, is actually very good to be used when you want to have a general view of your data. Okay, when you want to have a general view of your data. For example, this case, okay, you can see the popular birthday in US. Okay, so you can see from here. Okay, I know it's very good for a general view. For example, I want to know how many, I mean, what is the most popular birthday? Okay, so from here I can see the popular birthday is from July to September or maybe October. You see, these are the popular birthdays. So less popular birthday will be maybe from January, February, etc. So less people birthday during that month. Okay, but there's no detailed view for this heat map. You see, so if you ask me how many people birthday in the 1st of January, there's no answer for that. You see, how many people birthday in the 31st of January? No answer for that. We only know the scale. You see, so heat map is good if let's say you just want to have a general view. Okay, a general view. Yeah, for example, this case, you want to know whether the vaccine is effective for a certain disease, so you plot a heat map. You see, so from here you can know, oh, okay, after the vaccine is introduced, yeah, the number of people affected is decreased. Okay, so reduce. So it means that the vaccine works. Somehow the vaccine works. But if you ask me, how many people, being infected in this cell or that cell, there's no answer for that. Okay, so because this is your general view, is not detailed view. Okay, so same goes for this case. Okay, if this one is the traffic in the Google Analytics. Okay, so you can see the traffic. Okay, so the peak hour is from 10 a.m. until 2 a.m. Okay, then it start to slow down the traffic, and it start again from 10 a.m. until 2. Okay, so you can see the traffic. Roughly, we know the less popular and the popular slots, you see. But then there's no, again, there's no detail view. There's no numbers over here to be viewed, to be seen. Okay, so this is the heat map. Okay, so far you have any questions that you want to ask before we proceed to the hands-on? So now we're going to do some hands-on here, which mean the plottings here on this all these graphics. Yeah. So yep. Any questions? All right. So if no questions, then let's us proceed to this hands-on. Okay, please launch your Anaconda and your Jupyter Notebook. Okay, we are going to do some plottings over here. At least you do something, yeah? Not to fall asleep, yeah? Okay, so, okay, I will wait for maybe 1 or 2 minutes for you to boot up your Jupyter Notebook, start a new notebook. Okay, then we shall proceed to the hands-on session. Okay, I've received a few questions. Open CSV file. Oh, no need to open any CSV file. It's just for you to boot up your Jupyter Notebook. We are going to do the hands-on together. Okay, this one will be provided to you after the hands-on session, so that you can really try by your own first. Okay, try, then later only okay, I release this template for you. Okay, so you need to try, then only you know what is the questions that you want to ask, what is the challenges that you want to that you will face, and etc. So I can help you to solve it on the spot. Okay. Yeah, so now you open a new blank one. Okay. So we proceed to the data visualization. Yeah. Okay, we proceed to the first one. Okay. So my practice is usually I will, when I do hands-on, okay, I will how to say, I will have a cell to collect all the package that I want to use. Okay, so that in future I just run this cell, then for the remaining one no need. But for now, I will also put it here for you. So in the future, this is for your future reference. So in future, you want to plot this line chart, then you can just copy the whole thing. No need to copy this one. Okay, but on practice, I will put everything in one cell, the package. Okay, so and also you will need to set your directory. Okay, if you remember, okay, this is for you to read your file in. Okay, is for you to read your file in. So if let's say you have a CSV file or you have an Excel file you want to read in, then you will need to set the right directory. In case if you forgot, okay, let me repeat again. Okay, for the directory, CD. So you go to the place that you save your file. Let's say I save my file. Wait, what happened to my, okay, so let's say I save my file over here. Okay, I save my file over here. All right, in the hands-on folder. So I can click on my directional bar, right click, and then copy. Okay, so this one is actually a trick for you to avoid the typo error, the spelling error, etc., etc. Okay, so if you use this method, then it will be much more easier. Okay, and you can avoid all those things. Okay, careless mistake. Okay, so just copy and you paste it. Because if for Python actually it's a case sensitive. Okay, if let's say you go without you know the wrong entry of the uppercase, lowercase, spacing, then you will not able to run it. Okay, so you paste it over here, then you change the slash to the backslash. Okay, then you run it. Okay, then you will able to set your directory correctly. So later when you have any output, any input, then it will crawl from this folder. Okay. So this is for your starting, okay, to set your directory correctly, and then to I mean for my case, okay, personally is to collect the input, sorry, the package that I might want to use. Okay. So if you're ready, then we will proceed to plot the first plot, okay, which is our line chart. Okay, our line chart. Yeah. All right. So first we plot a simple one first, then we customize them. All right. So we use the matplotlib library. Okay. So for this figure size actually is optional. This is for you to make changes on your figures. If you want a bigger one, a smaller one, you can change it accordingly. Okay. So in the Google Drive, okay, in your data set, I also give you one Word file. So all these data set actually I put in the Word file, you can just copy and paste it. Okay, you can copy and paste it. So no need to spend time to type the data set. Okay, so for this data set, I just pump in here first. Okay, so the later we can read in from the Excel file. Okay, so if let's say you want to input directly, you can use this function. I use I mean this is the input and I name it as values. Values you can name it as any name that you want. Okay, so just remember to change it over here later. Okay, so I plot a simple line charts. Okay, I plot and then I just show. You need to show, then only you will see this. You go without this line, then you will not able to output your charts. Okay, you will not able to output your charts. Yeah. All right. So yeah. So I also prepare this write out for you. Okay, this is the explanation for each line for your future reference. In case if you forgot, then you can refer to this one. Okay, so yeah, maybe just a quick, maybe a few minutes, okay, for you to um try. Okay, before we proceed further. Okay, maybe just 8 minutes. Okay, for you to try. Okay, then we will proceed to the customization. Okay, after you try this, yeah. Okay, so just do a quick try. Okay, if you have any question, then let me know. Thank you. Okay, the figure size, this means you set the the resolution of your figures. Okay, so if you want bigger one, then you put a higher number. If you want a smaller one, then you put uh, smaller values. Then it will become bigger or it will become smaller. Okay, but this one is optional. You can obsolete this as well. Then you can also get the lie chart. Yeah, but just this is just additional information in case if you want to scale up or scale down your figure, then this will be a good option. Okay. So yeah, I've seen a few of your friends has done this. Thank you very much. Okay, so we proceed to the customization. Yeah. Okay, so for customization, if let's say, okay, just now you plot only one simple line chart without any labels, any only one set of data. Okay, what if I have two set of data and I want to plot it side by side? Okay, and if I have two set of data, I want to plot it side by side, and I want to have a legend. So what should I do? Okay, so this one you can get the data from the Word file, yeah. Okay, so for this sales data, okay, previously I have only one. Okay, so now if I have another set of data, okay, so I will have two sets of data. Okay, so two set of data. So I will plot two line chart 1 and line chart 2. You can name the line chart 1 and 2 as any name that you prefer. Yeah. So this one is optional. Okay, you can name it as any name. Okay, AA, BB, CC or something. Yeah, any name that you want. Okay. So you plot your first line is the sales 1 and the second line is a sales 2. Okay, then of course if you want to put some title, over here, so you can put the plot, okay, title. Okay, so you put in your title over here. Okay, then you want to label your x and y axis. Okay, your x axis sales, and then your y axis month. Okay, so you have the sales and the month over here. Okay, so as your x and y label, this is also optional. Okay, if you want, then only you label. If you don't want, then it's okay. It will still run. Okay, the program still run. It still works. Okay, legend is also optional. Okay, legend is this one. Because you have two lines now, so you don't know which line is which line. You see, which one is the 2016 and which one is the 2017? You don't know. Okay, so you have to call out a legend. Okay, so this legend, okay, you can name the first one, the first set of data, what do you want to name it as? The second set of data, what do you want to name it as? Okay, then you just show it. Then you will get your line chart with the proper label, proper legend, and with two lines. Okay, so you might want to try. Okay, and later we will proceed further for further customization. Okay, so this one, location for, also a popular question. What does it mean by this location for? LOC is the location of your legend. Okay, so it will be 1, 2, 3, 4. Okay, one over the top right corner, top left corner, bottom left corner, and the bottom right corner. Okay, so it will be you can put your legend in different location, different position. Okay, you can also put until 4, 5, 6, 7, 8, 9, 10. Because it will move around in your chart. But the most commonly used one is 1, 2, 3, 4, which is at the corner of your chart. The one is the most commonly used one. Okay, but you can also try 3, 4, 5, 6, 6, 7, 8, 9. So it will move around like at the middle, at the bottom here, or at the center. Okay, you can try different numbers. So it's just to play around with. Okay, but of course, normally we would just use 1, 2, 3, 4. Okay. So you can, this one again, the write up is for your future reference. In case if you forgot, then you can refer back in the future. Okay, so you can try this. Okay, there's one questions. Location 4. Location 4, it means the location of your legend. This one, this what was it? The rectangle thingy. So the label of your legend. So location 1 is over here, 2 over here, 3 over here. It's the position of your legend. So if you want to change, like maybe sometimes your line, you see over here is not suitable. You see, because it will clash or overlap with your line. So you might want to adjust to other corner, other location. So yeah. Yeah, the location for this is the meaning lah. Okay, thank you. Okay, so the legend has to there's one question, yeah, is follow the order of the data if you have a big data. So big data you means if big data in terms of the number of elements in your data, I mean in like sales 1, sales 2, then it will not affect anything lah. Just you will have a compact graph only lah. But if let's say you have more features, if your big data, it means you have more features, more column, then yeah, you will need to manually put in, or usually you will use Excel lor. You import from Excel file, then it will be much more easier lor if you have a huge data set. Yeah, the principle is the same, just that you import from Excel file, because usually if you have big data, you won't key in one by one from here manually. Yeah. So of course you will still need to key in manually for, I mean, you still need to name your legend because this is your own preference. So you want to name it as what, right? The machine will not able to do it for you. Like ABCD, even if they name it for you, I mean, it's also very difficult for the audience to know what is the meaning of that. So you yourself will need to put in the name of the for this legend. So no matter how manually input is needed for this naming purpose, like your title, your label, all those are manual input. But if you mentioned that in terms of the typing, like you want to have sales 2016 until 2024, let's say, so you can just drag in the Excel file, you just drag and then you pump in over here. Then you can do this. Or maybe you want to use a for loop, but the one I don't think we need until the extent. But yeah, so that's it for the big data. Yeah, thank you. All right. So we proceed further, yeah, to more customization. All right. So if let's say you will mention that, oh, I want a patterns line. I don't want the normal line. I want something special. You see? So this is what you can do. Okay. If you want to have a dotted line, so this one I select a few for you lah to put it over here for your future reference. But there are a lot more. Okay, there are a lot more. Okay, so you want to have a solid line, so it's just one dash. If you want to have a dash line, you will have two dash. If you have a dot line, dot line, then dash dot, dotted line, so it's a colon. Okay, so okay, so you just need to top up this one at the, so before this you already have your code, right? So you just want to top up this one over here. Yeah, you top up this one over here, then you will change the patterns. So if let's say you want to have a dash line for your line 1, so you put over here the pattern, then it will become a dash line. Okay, if you want to have a dotted line, then you put a dotted column over here, then it will become a column, a dotted line. Okay, so this is for you to customize the style or the patterns of your line, okay, for your line chart. All right. So if let's say you say that, okay, I want to change color. Okay, I want to change color. So in your Google Drive, okay, I have provided to you the color code. Okay, the color code. So you can select the color code that you prefer. Okay, and then put it in over here. I put a few commonly used punya color over here for your reference. Okay, for your future reference. So you can use this. Okay, just put it over here again. You just put a G, then it will become green color. If you put an M, then it will become magenta color. Or any colors that you prefer, you can just put it over here. Then you will get different colors punya line. Okay, so this is about the customization of the colors and also the patterns. Okay, so the remaining are the same. The code are the same. Just we add top up the customization. All right. Then we proceed further to the histogram. Okay, so this is how a histogram looks like. Okay, how a histogram looks like. So the data set also you can get it from the Word file, yeah, in the Google Drive. Okay, so now we plot a histogram. We use the matplotlib again, and you use HIST function. Okay, histogram. Okay, HIST. This one cannot be changed. Huh? Okay, so it has to be HIST. Then values, meaning it will pump in the values over here, over here. Okay, then how many bar you want? You want 5 bar, 1, 2, 3, 4, 5, then you put 5. If you want 4 bar, then you put 4. Okay, so all this actually is optional. Okay, but I put it over here. The option that you have, I put it up here for you. Okay, for your future reference. Okay, in case if you want to adjust in future. Okay, but these are all commonly used one. Okay, commonly used one. So the type, of course, we use a bar type, the bar chart. Okay, alignment middle. Okay, so it will align to the midpoint. Okay, to the middle. Color, I want a green color. Okay, you can refer to the color code that you have in your Google Drive, and I label it as a test score data. This one is actually optional. To me, it's quite redundant, but I just put it there in case if you want. If you don't want, then just delete it. Okay, just remove it. Okay, so test score data over here. Okay, then each color black. This one is also optional. Each color black is this one. You see, there's a line black color one. If you go without this, you remove this one, then um, it will be purely green. There's no edge. Okay, it's a purely green bar. Okay, so this is about the edge color. Okay, then legend. Okay, again legend. If you have this label, of course you want to have your legend in, so it will be over here. Okay, then your title, your histogram punya title, then you show it. Then you will get your histogram. Okay, maybe this one I think no need to try that because less popular. To me, it's less popular graph. Okay, for stats. Okay, but then just I mean I also want to fit it to you because I think that this is maybe you might use it. Okay, okay, that's one question. Can we customize both the color and dotted? Which one? Just now. Oh, the line chart. Yes, you can. I put it over here for you already. Here, this one. So I want a green color one and I want what is this? Dotted line. So you put both in, then you will get a green one with a dotted line. Okay. So this one is I put it over there for you as well. Okay. You just remove this in future, then you can use it. All right. So okay, thank you. Right, so we move forward to scatter plot. Okay, scatter plot is very important. Okay, scatter plot to me is the most widely used plot or charts in stats. Yeah, so I have put in the marker over here for your future reference in case in future you want to change to different pattern, different markers, then you can put it over here. Okay, so the height and width, I think I put it in the chat box in case if you want to copy, but it's already in the Word file as well. Okay, so this is how a scatter plot looks like. We will plot a scatter plot when we have both continuous variable, both numbers. Okay, so since we have height and weight, both are numbers. Okay, so we will use a scatter plot. So you will decide, okay, you yourself will decide what is the charts that you want to use with the data that you have in your hand. Okay, then you can use the tools to perform the plotting. Okay, so so now we use the scatter function. Okay, this one cannot be changed. It has to be scatter. Okay, so we plot the weight versus height. Okay, your weight versus your height. Okay, your weight versus height. And then the colors, what is the colors that you prefer? Choose from the color code. Okay, and marker is this one. You have star shape, you have diamond shape, you have whatever shape. So the most commonly used one is the round shape, the dot. So I put a few options for your future reference. Yeah. Okay. So you can choose your marker. Then you have the remaining are the same. The label, X label, Y label, the title, and then you show the chart. Okay, this one is also for your future reference, the explanation for each line. Okay, please try this one. Please try. So because this one is very important, okay, it's important for stats. Okay, one of the most important charts. All right, so you can try this, and we will resume after that. Okay, so please try. There's one question. Why I name it as weight one and weight two? Height one. Oh, this one actually you can put any name that you want. So I put this is because later I have weight two and height three and height two. So I just use this lah. But you can use any name AA, BB, CC or anything. Try one, try two. Yeah, any name. Yeah, thank you. Okay, there's one questions. Got error value X and Y must be the same size. You need to check your whether there's any typo or not in your data set. Okay, whether you named it because it mentioned that you have different numbers of your weight one and height one. You check the number of entry that you have. It has to be the same number. Okay, I think there's just this one is it means that there's some typo there. Yeah, you check your weight and the height. Okay, if cannot, then you share your screen. Oh yeah, the colors can be changed. Later we will proceed to the customization. Then you can change the marker, the colors, etc. Okay, so yeah, we will proceed to the customization soon. Thank you. your current dot is blue is because of this one. You see, I put my color dots as blue. You can try to change like green, red, then you can see different colors. Yeah. You marker O is for marker is this one. This one, you have the round circle marker. You see? Later you can put a star one, you see? A star. So I put a few option for you here. You see, if you want a point, you want a pixel, you want a circle, you want a rectangle, you want the octagon, you can change in the future. Okay, for now I choose circle. Yep. The C is the color that you want. Can customize that. Yep. Thanks, Sunny. Okay, so let us proceed further. Okay, so now says if we want to plot something like this, okay, if we have three sets of data instead of one, Okay, you see we have week 1, week 2, and week 3. Okay, now I have 3 set of data. All right, so okay, so how can I do the plottings? Okay, you can also get this data from the Word file, yeah, in the Google Drive. All right, so in order to plot this into one chart, actually there are a lots of methods that we can use, but just use a most traditional one. Okay, which is we concate them first. Concate meaning we cantumkan the 3 set of data. Okay, so we use NumPy array to concate the 3 set of data. So instead of having 3 lists, okay, I want to concate them into one. So I concate week 1, week 2, week 3, I make it become a long list. Okay, so I concate my week 1, week 2, week 3, and then I concate my week height 1, height 2, and height 3. Okay, if let's say I proceed to the plotting, then it will become the same colors, you see, all stars. So I might not know which one is the first set, which one is the second set, and which one is the third set, you see. So what can I do is I will put colors in. Okay, I will put colors. All right, so I will put in colors. Okay, okay. So let's say for the first set of data, I want to use blue color. The second set of data, I want to use green color. The third set of data, I want to use red color. So I put into my color array. Color array, you can use any name that you want. Yeah. Then only I start to plot my scatter plot. Okay. So my scatter plot. Okay, my scatter plot. I want to have weight versus height and marker. Choose star marker. Okay, and color array. Okay, my colors, I want to use color array, meaning I want to equate this, follow this color, blue, green, and also red. Okay, so then I will have different colors. Okay, then a label height, label X, Y, and title is the same lah with the previous one that we learned. Okay, and again, this is the command, okay, for your future reference. Okay, the explanation for the importance line. Okay, then you will get your scatter plot like this. Okay, you can try. Okay, then yeah, do a quick try first. Okay, there's one question. So you can customize the marker. Yep, you can do like your color array, but usually it's not encouraged because it will be very messy if let's say you have so many types of marker and colors in one graph. So a proper visualization usually we have only one customization, which is either colors or either markers. Then it will be you know easier for the user to visualize. Okay, but yeah, the answer is yes, we can also do the same. Okay, so I think that's it for the first half. Okay, I think it's time for us to take a break. Okay, then we will resume after 1 hour lah. Okay, then we continue our hands-on later. All right, so you have any questions before we proceed to the break?
Yes, I have a question.
Yep.
Okay, so do you have to write import NumPy or import MATLAB at every run
Nope,
run
nope,
program, or we have
no.
or it's already enough to write it on top?
Yep. Uh, for this one, I write it over here is for because to ease your future reference. If let's say in future you want to plot a scatter plot, then you can just copy this cell punya code in. So no need to copy the package up there and then come down. You see, but in future, I mean, practically this import NumPy, import Matplotlib only need to do once in one Jupyter notebook. So if you already do it upstairs, then no need already for the belowing one. Okay, but just this one is this one is actually the template that I prepare for you for your future reference. So in future, if you want to plot scatter plot, then you copy the whole cell, paste it, then you can use it. If you want a line chart, then you copy the whole line chart, then you paste it. Okay, then you can use it. Okay, so yeah, you just need to do it once. Yeah.
All right.
Any more questions? Thank you.
Thank you.
I want to ask about the color array. Why we have the color code times 15 plus color code times 17, the times the star and then the number.
Because this one for the blue color is the first item colors. The first item punya color. So I have 15 elements, 15 entries in the first weight one. So the first 15 point I want to plot it as blue color. The second 17 point, this one I have 17 entry. Okay, so I want to put it as green color, and the remaining 15 point I want to make it as red color. You see, so 15 entry, 17 entry, and then 15 entry. So if you have 10, then you put 10 entries. It's the number
Oh,
of entries that you have in your list.
we need to know the number of entries every time.
Yeah, if you want to change the colors.
Oh, okay. Thank
Yeah.
you.
Thank you. All right. Okay, if no more questions, then we proceed to a break. Okay, so I will see you after 1 hour. Thank you.
Oh, sorry.
Good afternoon, everyone. Welcome back. So, we have 27. Okay, maybe we okay, 29. All right. So maybe wait for another 1 or 2 minutes, okay, to see if our friend turns up. Then we shall start the session. Yeah. Thank you. All right, I think we have good number to start now. All right, good afternoon again, everyone. Welcome back, okay, to your hands-on session. All right, so now we have learned about the plottings, okay, for the statistical charts, okay, until scatter plot. All right, so now we are going to resume back, okay, for bar chart, yeah, and also bar plot. Okay, so for now we will plot a simple bar chart first, then we proceed to the customization. All right, so let's say we want to plot a simple bar chart. Okay, so first we will, oh, this is the data. Okay, we have 5 different cities. Okay, so for this post-it, yeah, the NP arranged length city, for this one actually is optional. Okay, this is actually optional, which means you want to count the city, the length of the city. Okay, the length of the city, which mean city is this one, right? This one you can name it as any name that you want. Yeah. So we want to count how many items we have in this city. Okay, the list name city. Okay, so we have 1, 2, 3, 4, 5. So meaning to say is 5 lah. Okay, so this one actually is optional. If you want, then you can use. If you don't want, then we use a traditional way. Okay, so this one is the good thing is to automate or automate, okay, the function, which means in future, if you want to top up more cities over here, blah blah blah, then you no need to change the numbers down here. Okay, okay, so this one, for example, okay, if you put the you automate the calculation of the length of the list, okay, then over here you have a post, over here you have another post, so you no need to change all this. Meaning in future, let's say I add another one, city A, okay, so it becomes 6. So I no need to change this 6, change this to 6, like this. Okay, no need. I just top up the number of cities, then that's it. I can run the code already. Okay, so it has been automated. So if not, then I will change here. I will change to 6. Change to 6. Okay. So this is the happiness index of each city. Okay, so I have 60, 40, 70, 65, and 85. Okay, so first I want to start the plotting of the bar chart. Okay, so bar post, meaning the number of elements that you have, meaning the number of bar that you have. Okay, post happiness index. Okay, happiness index is this one. Okay, so you want to plot the bar chart, 5 bar based on the happiness index. Okay, and the color, I want to have blue color, each color black. Each color actually is optional. Okay, if you don't want, then you will get a pure blue color bar. Okay, so this X tick, yeah, X tick is this one, the label of your x-axis. Okay, so what do you want to label for your x-axis? I want to label my x-axis, which is the 6 bar, by the city name, the name of the city over here. Okay, so city. Okay, so X label, Y label, and the title will be the same. Yeah, all right, so you can try. Okay, then this is the description for your future reference. Okay, so please do a quick try and we shall discuss, okay, after some time. All right. Okay, anything can let me know. Thank you. All right, so now we proceed further. Okay, if let's say we want to have a horizontal bar chart, okay, so what should we do? All right, so you can see from here, okay, so actually we just need to top up another alphabet over here. Okay, previously we used the bar function, so now we include an H over here. Okay, so we include a H over here. So it becomes a horizontal bar chart. Okay, of course the label you need to change as well, yeah. Okay, then it will be a horizontal bar chart. All right, so this is just a quick one. So let us look at this stack bar chart. Stack bar chart actually not being widely used. Unlikely that we will use this, but yeah, just to introduce this function to you. Okay, so we can do a stack bar chart. Usually we don't use this because it's less informative, you see. It's very difficult to know uh the amount, okay, above or below still okay, but above one is very difficult. So unlikely you will use that. But this one just to introduce to you for this chart. Okay, how do we plot this chart? Okay, so if let's say now we have two gender, we have male and female. Okay, we want to include it into this happiness index. Previously, we have only one set, which is the mixture of the happiness index of male and female. Okay, so now we use the same function, but now we have two set of happiness index. We have a happiness index of male and the happiness index of female. Okay, so the one that you want to plot at the bottom, okay, which means for this case is the happiness index of male. Okay, this one you want to plot at the bottom. Okay, so this one we use the we will go first. Okay, we will go first with this happiness index that we want to be at the bottom. Okay, so I want to have a happiness index of male at the bottom. So I will I will declare this first before I go to the one that I want to declare on the top. Okay, so the bar chart, okay, post is of course the number of items you have. Happiness index of male is the one that I want it to be at the bottom. Color is blue color, edge color black. Okay, so the second one, I want to have another one, but it's stacking on the first bar chart. Okay, so again, the same thing holds. Happiness index of female. I want pink color. Okay, but it will be the bottom of this happiness index of male. Okay, the happiness index of female will be the happiness index of male. So bottom equals to happiness index male. So happiness index of male will be at the bottom. Okay, so the remaining one are the same. Okay, so for this case, if let's say you want to add a legend, okay, you can do so. Okay, you can do so. This one, the legend. Okay, so you can just ask for the location. Okay, so you just put over there. All right, then you will have a stack bar chart over here. All right. Okay, so this is a stack bar chart, but yeah, this is just for your information, yeah. Okay, for a stack bar chart. Okay, so now we proceed to another important graphs, okay, which is the box plot. Okay, box plot is important. It's another important graphics. Okay, in stats beside the scatter plot. Okay, box plot is also widely used. All right. So let's say I want to plot 4 box plots side by side. Okay, the values you can get it in the code file. Okay, so what should I do? Okay, I can put it in one list. Okay, and I name it as box plot data, or you want to name it as any name that you want. Okay, so you plot the box plot. Okay, we use a box plot function, yeah, box plot function. So what is the data that I want to put in is the box plot data, okay, which is the name. I name it over here. You can use any name that you want. Okay, patch artist equals to true, meaning you want the bar chart to be filled. You want the bar chart to be filled, yeah? Okay, so labels, course 1, 2, 3, 4. This one you can use any label that you want. Okay, then you show it, you will get your basic bar, basic box plot. Okay, basic box plot. Okay, what kind of condition that we will use NumPy function? NumPy function is actually, I believe you learned it in the first module. Okay, so NumPy function is actually for this specific case, like you want to count, you want to count the length, you want to count the bar, you want to count something, or you want to input some array. So you will need to use NumPy. Basic plotting function actually don't need. But this one, because we want to automate the counting, everything, so I will use the NumPy function. Okay, so NumPy function is actually not really related to the visualization partner, but it's bit of automation. Sometimes you want to automate something like you do the for loop, if else loop, all those, then you might want to import NumPy. Else actually don't need. Okay. All right. Okay, so you can try this. Then later we will proceed for the customization. Yeah. Okay, another question. What is patch artist equals to true? Patch artist equals to true is this one, the fill blue color one. If you go without this patch artist equals to true, or you put a false over here, then you will get an empty empty box plot, meaning you will get this black color um edge only without the filled blue color, no blue color. So it's an empty box plot. True meaning it will fill it with colors, the default colors. Okay. Yeah, that's one question. Is the line in the box showing the mean value? That is the median. Um, the values and the calculation for each point actually you can be seen in your this one. I think I put it somewhere here. This one. So you can see that this is the meaning of each one, and the calculation the equation for each point is actually here. Okay. So these are the points. So the middle line is actually the median here of the box plot. Okay, so now we proceed further. Okay, if let's say we want to have a horizontal box plot instead of a vertical one. So just now the one that we plot as a vertical box plot. Okay, so now let's say you want to have vertical, a horizontal one. Okay, so actually we just add this in. Okay, this clause, okay, vertical equals to 0, so it will become the horizontal box plot. Okay. So this is just one phrase, okay, for you to make it into a vertical, a horizontal one. All right. But if let's say, because this one is in same colors, if let's say I want to put it in different colors, so how should I do? Okay. So you can actually set the colors. This one is the same, yeah. Okay, this one are the same. Okay. So we set the colors. Okay, we set the colors. Okay, let's say I want my first one to be cyan, the second one to be light blue, light green, tan, or any color. You can choose from the color code that I have provided to you, okay, in the Google Drive. Okay, you set your colors. Then we set the face color now. Okay, we set the face color of the box plot. Okay, so this is actually the function for you to set your face color. Remember, this is a tab, yeah, not space. Okay, so we use the for loop. Okay, we set the face color one by one. Okay, by colors. Okay, so we set the color. Okay, cyan, light blue, light green, and tan, and then we show it. You were able to see your box plot in different colors. Oh, there's one question. Why the box plot that is 2 circle below the cost 1 box? Because there's the outliers. So for box plot, it's very easy for you to see the outliers. There's 2 outliers in the cost 1 punya box plot. So that's why there's 2 circle there. Yep. Okay. So yeah, you can try the colors one. Okay, then we proceed to the next one. Thank you. Okay, there's one question. Box is not defined. You check the spelling, yeah. I think this is, you define the box equals to pie plot, the PLT box plot, etc. So once you define, then only you can set the face colors. Yep. Thank you. So that's it about our hands-on, okay, on the visualization part. All right, so far you have any questions that you want to ask for the part one of your hands-on, okay, which is on the visualization part. Okay. So if you have no questions, then we should proceed further to our confirmatory data analysis, which is the last part for today's sessions. Okay, so we learned a bit about the theoretical part, okay, which is the key terms that we need to know, okay, before we can proceed to do the analysis. Okay, so today we will learn about the one sample t-test, two sample t-test, pair and independent sample t-test. Okay, so pair and independent sample t-test fall under the two sample t-test. Okay, so before we go, so just now we have covered the exploratory data analysis, yeah? So you should suppose we already know how to do this descriptive study, say, visualization, measure of central tendencies. All right. So now we proceed to the one sample t-test. But before we proceed to the one sample t-test, there are a few key terms that you will need to know. Okay, there are a few key terms that you will need to know. So estimation and confidence interval. Okay, so what is a point estimate? Okay, what is actually a point estimate? Okay, so point estimate is actually similar to the population mean. You see? So for example, if let's say you want to know how much amount spent, okay, by the tourists that visit a country. Okay, so let's say you want to know the amount spent by the tourists visit to the country. But there's so many tourists, visit to one country. So it's impossible for you to ask every of them, okay, like how much you spend during your visit, etc. Then you add up all of them and you get the average, right? So in order for us to do so, okay, we use the sample mean, okay, which is the point estimate, where we randomly select 500 tourists, okay, and we ask these 500 tourists how much they spend, okay, when they visit the country, okay, how much they spend when they visit the country. So we take this average of this population mean of this sample mean, okay, and then uh you get this, let's say you get 500 ringgit. Okay, so meaning to say this 500 ringgit is the point estimate for your population. Okay, is the point estimate for your population. Right, so we will estimate all the tourists that visit the country, okay, will spend around 500 ringgit. Okay, so this is how, okay, this is the meaning of this point estimate. Okay, so we have another term, which is the confidence interval. Okay, which is the confidence interval. So what is the meaning of this confidence interval? All right, so let's say just now we talk about the spending, okay, the spending of the visitors here to the country. So it's impossible for everyone to spend the same amount, right? So some might spend more, some might spend less, you see. So it's reasonable for us to have a confidence interval where let's say you have 500 ringgit as the average, but we have a lower confidence limit and upper confidence limit so that we can know let's say the tourists spend around 450 to 550. Okay, so we have a plus minus 50 ringgit. So it make it more reasonable, okay, so that we know the tourists come, they will spend around 450 to 550. So it make more sense. Okay, so that is the meaning of the confidence interval where you have a range. Okay, you have a lower confidence limit and upper confidence limit. Okay, so this is the notation for the population and the standard deviation and the sample. Okay, the means and the variance. But just for your information, yeah. Okay. So confidence interval I have explained just now. Okay, so which mean is a range. Okay, is a range rather than a specific number. Okay, the mean. So population mean is unknown. Okay, we don't know the population mean. So in order for us to estimate the population mean, we use some sample, and from there we get the sample mean. Okay, let's say sample mean is 50. So we will calculate the confidence interval. Okay, you just put in the um dummy into the equation and perform the calculation. So let's say 40 to 60. Okay, so it is reasonable for us to say that okay the people okay or maybe the age is around 40 to 60 instead of 50. Okay, not everyone have the same age, right? So it's less reasonable. So it will be more reasonable if let's say we put it a range, okay, and we say that the age is around 40 to 60. And we also have another key term, which is the confidence level. Okay, confidence level. So for confidence level, okay, confidence level, you can set, okay, you can set certain numbers, but the most popular or the most commonly used confidence level is actually 95%. Okay, it's actually 95%. So this has been proved by a few researchers to saying that this is the most commonly used or the most popular confidence level. Okay, 95% confidence level. A 95% confidence level, it means how much confidence that you have when you say the entries is between 40 to 60. Okay, so let's say you mentioned that the tourists spend between 450 to 550 ringgit. So what is the confidence level that you set? If I set 95%, so it means I have 95% confidence the visitors or the tourists visit the country will spend between 450 to 550 ringgit. Okay, so meaning to say there will be 5% of the tourists spend outside the range. They are outliers. Okay, maybe this makes sense. There must be someone who spend a lot more than the normal, okay, or far more less than the normal. Okay, so 5% of them are out of the range. Okay, so this is the meaning of this 95% confidence level. Okay, so this is one example. If let's say they want to know the salary of the store manager, okay, they want to know the salary of the store manager. So they calculate so it's impossible for them to ask everyone in the country. So what is your salary? Okay, what is your salary? So it's impossible for them to ask everyone. So they randomly pick 49 managers and they ask these managers to reveal their salary. Okay, and they get the mean of the salary of these 49 managers, okay, which means the mean is 45K and then the standard deviation is 2K. So what is the population mean? So again, we do not know the population mean. Okay, we do not know what is the population mean of this case. Okay, we don't know. All right, so we use the sample mean to represent the population mean. So we assume that all the managers' punya salary is about 45K. But it's impossible to have to get everyone, all the store manager to have the same salary, right? There must be a range. So what is the range? Okay, which is the confidence interval. We plug into the equation and you get the interval is around 44846 to 45994. So it's around this one, 44846 to 45994. Okay, so it means that the salary, okay, of a store manager in that country is around 44846 to 45994. Okay, so what is the how to interpret the results? Okay, so if we mention that we have a 95% confident, so it means 95% of the store manager's salary is between 44846 to 45994. 5% of them might have a very high salary or a very low salary. lower or higher than the range. Okay. So this is the meaning of the confidence level. Okay, and also the key terms. Okay, then we have to proceed to the statistical test. Okay, so in this module, you will learn about all these statistical tests. Okay, but the key roles of the statistician or the data analyst or data scientist is to determine when to use which. The calculation can be done by the tools, but the selection of the techniques has to be done by you as a data scientist or a data analyst. Okay, so when to use which is very important. So we will look at it one by one. Then later we will learn how to combine all this and apply it to a real world data set. Okay, so this is for your future reference. If you have both continuous variable, okay, EDA, we will do a scatter plot, and CDA, we will use correlation analysis or regression analysis. If you have one continuous variable, meaning one numbers, and another one is nominal or ordinal variable, which mean non-numbers, categorical variable, then you will use box plot. Okay, CDA wise, you will use the two sample t-test or one way ANOVA test. So same goes for this case. If you have one nominal output, okay, which means you have one categorical output and one continuous input, we will use box plot as well and a two sample t-test for CDA. Okay, and if you have both categorical variable, both are category, then you will plot a bar chart or mosaic plot. And CDA wise, we will use a chi-square test. But this is for your future reference. Later, I will walk you through one by one. Okay, so when to use which, yeah? We look at the t-test. So this is the summary that I prepare for you. Okay, this is for when to use which. Okay, so we will use t-test, okay, one sample t-test when you have only one group. Okay, when you have only one group and you want to know if the population mean of the group is equals to smaller than or greater than a specific value. For example, you have only one group. You want to know whether the group of the student, okay, the group of the student is 9 years. Okay, I want to know whether mu is equals to 9 or not. So I have only one group and I want to know whether it's equals to greater than and smaller than a specific value. So I will use one sample t-test. If I have two groups, I will need to use the two sample t-test. Excuse me. Okay, so if I have two groups, I will use the two sample t-tests. And if the two groups are dependent, for example, I have before you attend the course and after you attend the course. I have two groups. Your marks before you attend the course and your marks after you attend the course. Before and after, two groups. And the two groups are dependent because the same people before they take the exam and after they take the exam, they are still the same people. So for this case, we are going to use the pair sample t-test because they are dependent group. Okay, but independent group, if you have two groups, let's say you want to compare the salary of male and female. Okay, so the salary of male and female, there are two independent groups. There's no relationship between the two groups. So we are going to use the independent sample t-test. Okay, so when to use which is very important. You need to know, yeah, because the tools were not able to help you to perform the selection. Okay, so we'll proceed to the one sample t-test. Okay, so actually all these statistical tests, yeah, we can also call it as a hypothesis test. Okay, we can also call it as a hypothesis test. So hypothesis test is for us to see, okay, if we can verify or we can falsify a statement. Okay, you want to verify or falsify a statement, for example, okay, if let's say a manufacturer advertise a new hybrid car has the mean gas mileage of 50 miles per gallon. Okay, so you want to know whether this is true or not. Is it really 50 miles per gallon? Okay, or it is not. Okay, so you want to know, okay, whether this is true or not. Okay, so you can use the hypothesis test to perform the verification. Okay, so for statistical tests, okay, we talk about you will need to know, okay, how to set up the null and alternate hypothesis. Okay, you will need to know how to set up your null and alternate hypothesis. Okay, so later you will learn how to set up the null and alternate hypothesis, because the tools were not able to set that for you. Okay, you yourself as a data scientist or data analyst will need to set, okay, the null and the alternate hypothesis. Okay, so this is how you write or you state your null and alternate hypothesis. Okay, so when you want to know, okay, whether mu is greater than k is the specific value. So let's say I want to know whether the age of the class is the average population, yeah, age of the class is greater than 50 or not. So k is equals to 50. Or if let's say I want to know whether mu is smaller than 50 or not, so I will use this set. These are one set, one set, one set. So if let's say you want to know whether it's smaller than, so your null hypothesis will automatically be greater than or equals to. Okay, so if your null hypothesis is equals to, then your alternate hypothesis will automatically be not equals to. So they are the complement for each other. They are the opposite of each other. Okay, and bear in mind, the equal sign always belongs to the null hypothesis. Okay, the equal sign always belongs to the null hypothesis. All right. So later we will look at the example, then you will have a proper idea. Okay. So for the hypothesis, okay, we can state the hypothesis either by words, either by notation. Okay, as long as you can understand it, then it should be fine. Okay. All right. So for the first one, okay, let's look at this example. Okay, if a school published that the proportion of their student who involved in at least one extracurricular activity is 61%. So you want to know, okay, whether this 61% is true or not. Whether is it true, okay, their student, 61% of their student, okay, participate in at least one co-K. Is that true? So how to state the null and alternate hypothesis? Okay, so now hypothesis P is the probability equals to 0.61. So you want to know whether the probability is equals to 0.61 or not. Okay, so equal sign always belongs to the null hypothesis. Okay, while alternate hypothesis just the opposite of your null hypothesis. Okay, so P probability is not equals to 0.61. It means the percentage of the student involved in at least one extracurricular activity is not equals to 61%. Okay. So what if this case? So see how we state the null and alternate hypothesis. Okay, if a car dealership announced that the mean time for an oil change is less than 15 minutes, less than 15 minutes. Okay, so less than 15 minutes will be your alternate hypothesis, because equal sign always belongs to your null hypothesis. Okay, equal sign always belongs to your null hypothesis. So if over here is smaller than, over here your null hypothesis will be greater than or equals to. Okay, so this is how you state your, yeah,
Doctor, just now
Mhm.
the number one, right?
Number one. Okay.
Because the statement is at least one or is because it's 61%, so that's why equal to lah, not bigger or equal to 61%, right?
Yeah, this is
Ah,
so is a equal sign. Yep.
okay, because just now I
Yeah.
read at least, I thought at least 61%.
Oh yeah, this one is at
Sorry.
least one extra curriculum
All right,
activity.
all right.
Yeah. Yep. Okay, thank you. All right. So yeah, for this one also is less than 15, so less than, but if over here it mentioned that less than or equals to 15, then it will be less than or equals to 15. So we will use this set. Okay, less than or equals to 15. All right, so alternate hypothesis will be the other way around. Okay, so it depends on how I mean you state your objective and how you state, okay, and how you state the one, okay, and how you state your null and alternate hypothesis. Okay, so types of arrows. Okay, type of arrow. You have two types of arrow. Okay, when you say, okay, so for this all these statistical tests, yeah, all these statistical tests, the hypothesis test is all about the acceptance or the rejection of the null and alternate hypothesis. Okay, it's about the acceptance or the rejection of the null and the alternate hypothesis. Okay, so we will say that, okay, after we do the experiment, okay, we decide that now we will accept or reject the null hypothesis. Okay, we won't say that we will accept or reject the alternate hypothesis. Okay, but we will say, okay, so for this case, I accept the null hypothesis, meaning to say the mean time for the gas for the oil change is greater than or equals to 50 minutes, which mean their claim is not right. Okay, if I reject the null hypothesis, it means that I agree with this one, meaning to say, yeah, the population mean is really smaller than 15 minutes. Okay, so later we will look at more example, yeah, to have a clearer idea. Okay, so when we say we accept the null hypothesis, how true is that? Okay, how accurate is it? Okay, so if the actual answer, actual decision, yeah, if the null hypothesis is really true and you accept the null hypothesis, so you have made a right decision. Okay, but if the null hypothesis is false, but you go and reject the null hypothesis, meaning to say we have made a type 2 error. Okay, if the actual answer is correct, which is true, and you reject the null hypothesis, which means you have made an error, which is a type 1 error. Okay, and if the actual answer is false and you reject the null hypothesis, so you have made the right decision. So this is just to tell you that there are two types of error, which is the type 1 and type 2 error. Okay, so this is the level of significance. So level of significance is the opposite for the confidence level that we learned just now. Just now we mentioned that the most popular confidence level here is 95%, right? 95%, meaning to say 5% of it might be wrong. So when you say you reject the null hypothesis, how much confidence that you have? Okay, meaning to say I have 95% confidence I'm making the right decision. 5% might be wrong. Okay, I might be rejecting the wrong hypothesis. Okay, so this means that how confidence that you have on the decision that you make. Okay. So when you say you want to accept or reject the null hypothesis, okay, based on what? Okay, what is the indicator for you to accept or reject the null hypothesis? Okay, it's based on the p-value. Okay, it's based on the p-value. So p-value is the indicator for us to decide whether we want to accept or we want to reject the null hypothesis. Okay, later I will show you more example. Okay, and we have three types here of hypothesis tests. Okay, the first type, it is the left tilt test. Okay, which means if you use this set smaller than, okay, smaller than, then it is a left tilt test. Okay, if your alternate hypothesis is greater than, then it is a right tilt test. Okay, if it is an equal sign, then it is a two tilt test. Okay, so you have right tilt test, you have left tilt test, and you have two tilt tests. All right. Okay, so this is the decision rule. Okay, when we say p value is the indicator, so how are we going to decide based on the p value? Okay, if your p-value is less than or equals to 0.05, you have to reject the null hypothesis. Okay, so if your p-value is greater than 0.05, so we have to accept our null hypothesis. Okay, you accept your null hypothesis. All right, so this is the decision rule, yeah? So we look at this example, then you will have a clearer idea. Okay, so let's say a department, yeah, or maybe you spend 1 minute to read this, then I will summarize this for you. Okay, so let me summarize this for you. Okay, so let's say a department of the motor vehicle office. Okay, we claim that the mean waiting time is less than 14 minutes. Okay, so says that people claim that their waiting time is less than 14 minutes. Okay, so a random sample of 10 people, okay, because there are so many people, okay, who visit the department, right? So it's impossible for you to ask everyone, what is your waiting time? What is your waiting time? And you record them down and you get the average of it. Okay, so to prove this statement, to see whether this is true or not, the waiting time is really less than 40 minutes. Okay, so they randomly select 10 people in the shop, okay, and they record down their mean waiting time, which is 30 minutes, and the standard deviation 3.5 minutes. Okay, so they want to see, okay, this statement, the mean waiting time is less than 40 minutes, okay, whether this is the true statement or not. Okay, whether this statement is really true. Okay, so first you will need to set up your own null and alternate hypothesis. Okay, so now hypothesis, okay, so the claim is the mean waiting time is less than 14 minutes, yeah? Less than 14 minutes, it has to be your alternate hypothesis. Because remember, the equal sign always belongs to the null hypothesis. Okay, so smaller than 14 minutes. Okay, smaller than 14 minutes over here. Okay, so your null hypothesis automatically will be greater than or equals to 14 minutes. Okay. So after you have set your null and alternate hypothesis, okay, we look at the p-value. Okay, so now we look at the p-value. So let's say p-value equals to 0.1949. Okay, p-value equals to 0.1949, which means it is greater than 0.05. So remember the division rule that we learned just now. Okay, if it is greater than 0.05, we cannot reject the null hypothesis. Okay, we cannot reject the null hypothesis. So we cannot reject this one. So we have to agree that the mean waiting time is actually greater than or equals to 14 minutes. Okay, greater than or equals to 14 minutes. So this is our conclusion. The statement is not true. Okay, their claim is not right. Okay, but the waiting time is actually more than or equals to 14 minutes. Okay, so this is how we conduct a one sample t-test. First, you have to set your own null and alternate hypothesis. Okay, the tools will not able to do it for you. You have to set your null and alternate hypothesis. Then you run the test and the tools will give you the p-value. Okay, all these values, so which value that you should refer to. Okay, also you will need to know. Okay, we refer to the p-value and what does it mean when the p-value equals to 0.19? Okay, so you have to know when the p-value equals to 0.19, it means that we have to reject the, we have to agree with the null hypothesis. Okay, so agree with the null hypothesis, which means we disagree with their claim. Their claim is not true. Okay, we fail to reject the null hypothesis. Okay, so this is for the one sample t-test. Okay, so far you have any questions that you want to ask for up to this point or one sample t-test before we proceed to maybe a small break? Okay. All right. So if you have no questions, then we will proceed to a quick break, a 20 minutes break. Then we will resume after 20 minutes. Okay. So I will see you after 20 minutes. Thank you. Hey, hello everyone, welcome back. All right, so we should proceed, okay, for the last part for today, okay, before we call out for the day. All right, so yeah, just now we have talked about the example for the one sample t-test. All right, so we look at another example, yeah, so that you have a clearer idea. Okay, so for this example, okay, they want to know, okay, how many surveys that has been conducted, okay, how many survey that has been conducted by the agent, okay, by the agent, okay, in the company. Okay, so they randomly pick 15 agents and they record down the survey that is conducted by the agent, okay, during a week. Okay, so they want to conclude, okay, they want to know, okay, they want to verify, okay, if the interviews or the survey conducted by the agent is more than 53 per week. Okay, if it is more than 53 per week. So we have only one group and we want to know whether it is greater than 53. Okay, so first step, you will need to state your own null and alternate hypothesis. Okay, so state your own null and alternate hypothesis. Greater than 53, it has to be your alternate hypothesis. Okay, it has to be your alternate hypothesis. Okay, because equal sign always belongs to the null hypothesis. Okay, so greater than 53 will be your alternate hypothesis. Okay, so look at the p-value. Okay, look at the p-value. P-value is smaller than 0.05. Okay, p-value is smaller than 0.05. So we have to reject the null hypothesis. So we reject the null hypothesis, meaning to say we agree with the claim. So we agree that the population mean number of survey conducted by the agent is greater than 53 per week. Okay, it's greater than 53 per week. Okay, so that is for one sample t-test. Okay, we will use one sample t-test when you have only one group and you want to know whether it is equals to, greater than, or smaller than a specific value. You have a specific value, so you will use the one sample t-test. Okay, so we will use the two sample t-test when you have two groups. Okay, when you have two groups. Okay, and if the groups are dependent, we will use the pair sample t-test. If the groups are independent, then we will use the independent sample t-test. Okay, so this is the sample for dependent and independent groups. Okay, let's say you have the fat levels of 70 patients, okay, as the first group, and the second group, the fat level of 70 patients after they use the fat lowering drug for 6 months. So you want to know whether the drug is effective or not for the fat levels. So before and after. Okay, before they consume the medicine, okay, you measure the fat levels. After they consume the medicine for 6 months, measure again the fat levels. So they are the same people, same group of people. Okay, so for this case, we will consider this as the dependent sample because there is a relationship between the two groups. So for this case, we will use the pair sample t-test. Okay, while for this case, first group, we have the score for 38 adults. Second group, we have the score for 50 adults. Okay, so we want to compare the score for 38 adult and 50 male adult, and this one is the male adult, young adult male and adult female. Okay, so their score, okay, for the two groups. Okay, so there is no relationship between the two groups. It's the score for the male and the score for the female. Okay, there is no relationship between the two groups. So for this case, we will use the independent sample t-test. Okay, so this is how you write your null and alternate hypothesis, okay, for the two sample t-test. Okay, for the 2 sample t-test, this is how you shape your null and alternate hypothesis. Okay, so for your null hypothesis, okay, mu1, mu2. So just now you have mu equals to k, right? K is the specific value. Okay, for now, because you have 2 groups, so there's no more k. Mu1, mu2, mu1, mu2. Okay, so the symbol is the same. Remember, equal sign always belongs to the null hypothesis. Okay, always belongs to the null hypothesis. Okay, so mu1 greater than mu2. So null hypothesis will automatically be smaller than or equals to mu2. Okay, so this is the same thing. Okay, if smaller than, so over here null hypothesis will be greater than or equals to. Okay, so the same division rule. Okay, if it is smaller than or equals to 0.05, we have to reject the null hypothesis. Okay, we have to reject the null hypothesis. So it means that it is statistically significant. Okay, if it's greater than 0.05, we accept the null hypothesis. So it means that it's not statistically significant. So what is the meaning of statistically significant and not statistically significant? Okay, for statistically significant, it means, for example, if let's say you want to know the medicine is effective or not to a certain disease, okay? So finally, if let's say you reject the null hypothesis, it means that it's statistically significant. So it means your medicine will affect, for example, the blood pressure value. Excuse me. Okay, for example, the blood pressure value. So it means that, okay, it will affect the blood pressure value. So it is statistically significant. Okay, so if let's say you accept the null hypothesis, okay, you accept the null hypothesis, it means that it's not statistically significant. So it means the medicine will not affect the blood pressure value. Okay, so it's not statistically significant. Or you want to know whether the course is effective or not to the score of the test, okay, the score of the students in your class. Okay, so if you reject the null hypothesis, it means that statistically significant. So it means the class or the lecture will affect the marks of the student. Okay, so if you accept the null hypothesis, it means that it is not statistically significant. So it means that the lecture will not affect the marks of the students. Okay, so meaning to say the lecture is not effective for the student. Okay. So first we start with the independent sample t-test. Yeah. Again, we will use the independent sample t-test when you have 2 groups and if the 2 groups are independent, meaning to say there is no relationship between the 2 groups. Okay, there is no relationship between the 2 groups. Okay, so you might want to take 1 or 2 minutes to read this example. Okay, then I will summarize this for you. Okay, thank you. Okay, so for this example, okay, they want to compare, okay, the allowance received by the children between 8 to 10 years and the allowance received by the children between 11 to 14 years. Okay, their belief is, okay, the mean allowance received by the children between 11 to 14 years is more than the allowance received by the children between 8 to 10 years. Okay, so they want to compare, okay, they want to compare the allowance received by the children. Okay, so first, okay, you will need to state your own null and alternate hypothesis. Okay, the tools were not able to help you to do so, so you yourself have to do it. Okay, so mu1 and mu2, so the claim is, okay, the mean allowance received by the children between 11 to 14 years is more than the allowance received by the children between 8 and 10 years. So mu1 is the allowance received by the children, okay, between 11 and 14 years. Mu2 is the allowance received by the children between 8 and 10 years. So mu1 is greater than mu2. Okay? So null hypothesis will automatically be mu1 smaller than or equals to mu2. Remember, equal sign always belongs to the null hypothesis. Okay, then we look at the p-value. Okay, the calculation will be done by the tools and you will get the p-value. Okay, p-value is smaller than 0.01, so we have to reject the null hypothesis. Okay, we reject the null hypothesis, and if we reject the null hypothesis, meaning to say we agree with the claim. So meaning to say we agree that mu1 is really greater than mu2. So we agree that the allowance received by the children between 11 and 14 years is more than the allowance received by the children between 8 to 10 years. Okay? So this is the example for the independent sample t-test. We have two groups and there is no relationship between the two groups. They are different people. So we will use the independent sample t-test. Okay, so this is another example. Okay, I like to use different examples so that it can give you a clearer idea on how we actually can conduct this independent sample t-test or other statistical tests. Okay, so maybe we take 1 or 2 minutes to read this, then I will summarize this for you. Okay, so let me summarize this for you. Okay, so for this example, okay, they want to know the time taken to solve the software issue, okay, whether it is longer than the time taken to solve the hardware issue. So they have two types of issues, okay, in the company. So they want to know whether it will take longer time to resolve the software issue compared to the hardware issue. Okay, so they have so first we will need to set up our own null and alternate hypothesis. Okay, the tools were not able to do this for us. We will need to do it by ourselves. First, okay, the mu1 we need to define. Mu1 is the mean time to resolve the software issue, and mu2 is the mean time to resolve the hardware issue. Okay, so mu1 is greater than mu2, meaning to say is their belief lah. They believe that mu1 is greater than mu2, meaning to say they believe that the time taken to resolve the software issue is longer than the mean time to resolve the hardware issue. Okay, so this is their belief. Okay, the belief that mu1 is greater than mu2. So equal sign always belongs to the null hypothesis. Okay, so automatically your null hypothesis will be mu1 smaller than or equals to mu2. Okay, so we look at the p-value. Okay, we look at the p-value. So p-value equals to 0.004, which means that it is smaller than 0.05. So we have to reject the null hypothesis. Okay, we have to reject the null hypothesis. So once we reject the null hypothesis, okay, meaning to say we reject this one, we agree with the claim. So we agree that it takes longer time to resolve the software issue compared to the hardware issues. Okay, so this is the conclusion. Okay, so that's it about the independent sample t-test. Okay, before I proceed to the last test, which is the pair sample t-test, do you have any questions that you want to ask up to this point? Okay, you have no questions, yeah? All right, so remember, okay, it's important for you to know which test to choose and how to set up your own null and alternate hypothesis. Okay, so we proceed to the pair sample t-test. We will use the pair sample t-test when you have two groups and the two groups are dependent. Okay, they are dependent, yeah? For example, okay, maybe you want to spend 1 or 2 minutes to read this, then I will summarize this for you. Okay, so for this example, okay, the vice presidents of the company, they actually noticed that there is an increase in the absentees recently, and they actually want to implement the fitness program. Hopefully, this can solve the issue, okay, to reduce the absentees. Okay, so they, of course, is a huge cost, okay, for them to invest to the whole company. So they, at first, they just select 6 participants. No, it's 8 participants, okay, 8 employee to participate in this exercise. And they want to see whether it is effective or not. Okay, if effective, then only they implement to the whole company. All right, so these are the selected employee, and they record down the number of days of absence before they attend the program and after they attend the program for 6 months. Okay, so this is the um, hypothesis, okay, the null and alternate hypothesis. Okay, for this is the claim. Okay, before greater than after, number of days before, number of days of absence, yeah, before they attend the program is greater than the number of days of absence after they attend the program. So before is greater than after. Okay, before is greater than after. So for this case, this is the claim. Null hypothesis will automatically be smaller than or equals to. And you can see before and after they are still the same people, meaning to say there is a relationship between the two groups. Okay, there is a relationship between the two groups. Okay, so meaning to say we were going to use the pair sample t-test. Okay, the pair sample t-test. All right, so we look at the p-value. Okay, so the p-value is greater than 0.05. So we cannot reject the null hypothesis. Meaning to say we have to agree with this null hypothesis. Okay, so meaning to say mu before the number of days before the number of days of absence before they attend the program is smaller than or equals to the number of days after they of absence, yeah, after they attend the program. So meaning to say the program is actually not significant. Okay, it won't help to reduce the absence. Okay, it won't help to reduce the absence. So meaning to say the vice presidents would either need to revise the program or he might want to think of another way. Okay, he might want to think of another way to make the program, okay, to be more efficient. Okay, so this is the conclusion. Or maybe he want to observe for another few months because it is only 6 months. Okay, only 6 months. So maybe he might want to observe for more than 6 months, okay, to see how it works. Okay, so this is the conclusion that we have.
Hey,
Anyone?
Doctor.
Yeah.
I have a question.
Yep.
How the result from Python is calculated? Because if I see the table before and after, the numbers of absenteeism after is less than before. I calculate it manually lah. So I want to know how the Python is calculated to get the 0.067.
Okay. Okay. Thanks for your questions. All right. So for your questions, okay, we need to know that, yeah, of course, if you look at this one, we have more than or we have less than. Okay. Both cases we have. Okay. So this one we have to bear in mind. This is the population mean. You see, this is the population mean. So they want to know the population mean, meaning to say the whole company. If let's say the whole company apply to this program, how actually it will works. So meaning to say this is just a sample to represent the population. Okay, so this is just a sample. So this cannot represent the whole thing. Okay, if let's say before and after this reduce, but then there's some this reduce and then this increase or something. So it doesn't mean that this will represent, okay, because this is just the sample mean. You see, sample mean is the mean of these these 8 people only. But what we want to do is this one. You can see we are looking at the population mean. Population mean meaning is the whole company lah, their population, the research, the interest of the research. You see, so we are comparing the meal after and meal before. So if we look at the overall, okay, from the experiment, okay, from the p-value, we know that we cannot reject the null hypothesis. Okay, so meaning to say the population mean before it will be smaller than the population mean after. Okay, so this is the conclusion that we get. Meaning to say if you get everyone in the company to participate in the program, okay, and after you compare the before and after, you sum up all the number of days of absence before they attend the program, divide by the number of people that you have in the company, you get mu before, right? Then you sum up all the number of days of absence after they attend the program, you get another numbers, which is your mu after, right? So you have two mu before and mu after. So bear in mind, we are comparing the mu before and the mu after, excuse me, not the sample mean. Okay, so the sample mean is to represent the population mean. Okay, so when we say that it's not significant, okay, there's no difference, it doesn't mean that we are talking about this one, but we are talking about the population mean. Okay, we are looking at the overall. Okay.
Okay, thank you, thank you.
Okay, excuse me. Okay, so this is the first question, and the second one is how we get the p-value. So from here, okay, we just look at the theory part. So later when we do hands-on, then I will show you the steps, okay, how we calculate the p-value, okay, by using Python. But then the equation, the calculation actually will be taken care by Python. So yeah, we have less worry on that. But again, we also need to know how we generate this p-value. So now is we learn about the theory, how to form this, how to interpret this, and then later we proceed to the hands-on. Then you will learn how to generate this p-value, okay, by ourselves, okay, by using JUMP and also by using Python. Okay, all right. So thanks for a question. Yeah, this is also a popular question as well. Okay, any more questions? Okay, all right. So
Good.
we yeah. No, yeah. Okay, so we will move to the last example. Okay, before we call out for the day. Okay, so maybe a few minutes for us to read this. Okay, then I will summarize this for you. Okay, so let me summarize this for you. Okay, so for this example, they want to compare, okay, the percentage they spend, okay, from they spend for the housing, the costs, okay, they spend from their monthly income, okay, whether it increased, okay, five compared to 5 years ago, okay, the percentage that is spent for the household spending. Okay, so they want to see, they want to compare. So they select a few house owner, okay, to perform the experiment. Okay, so first you will need to set up your own null and alternate hypothesis. Okay, so this is their claim. The percentage that is spent, okay, now is actually less than the percentage that is spent it was 5 years ago. So percentage spent now is smaller than it was 5 years ago. This is their claim. Okay, this is their claim. So null hypothesis will be the other way around, which is the percentage now is greater than it was 5 years ago. Okay, so this is your null and alternate hypothesis. Okay, and we calculate the p-value. Okay, and the p-value is 0.018. So it means that it is smaller than 0.05. So if it is smaller than 0.05, we cannot, we have to reject the null hypothesis. Okay, we have to reject the null hypothesis, so it means we reject this one. We agree with the alternate hypothesis. Okay, so we can conclude that, okay, the percentage spent now, okay, on the housing cost, okay, is actually less than it was 5 years ago. So we agree with their claim. Okay, so this is the conclusion that we have. Okay, so these are the statistical tests package or the library. Okay, I put it over here and the link also for your future reference. So in future, if let's say you want to do different tests, okay, you can refer to the link or you can refer to this one. So you just call out the relevant or the related tests, then you can use to perform the statistical test. Okay, so later we will learn how to do hands-on, okay, by using this Python, okay, package. Okay, so today we have learned about the t-test. Okay, you will use the one sample t-test when you have one group and you want to see if it is equals to, smaller than, or greater than a specific value. Okay, we will use the one sample t-test. Okay, if you have two groups, okay, and the two groups are dependent, okay, there is a relationship between the two groups. Okay, for example, before you eat the medicine and after you eat the medicine. So it's the same person. So we are going to use the pair sample t-test. Okay, and for if you have two groups and they are independent, there is no relationship between each other. So you will use the independent sample t-test. Okay, meaning to say there is no relationship between the two groups. Okay, so we will use the independent sample t-test. Okay, so these are the tests that we have learned today. Okay, and next week we are going to learn the remaining tests. Okay, and don't forget to install your jump tools, okay, in your machine, because next week we are going to learn jump. Okay, we are going to use jump to perform the hands-on. Okay, to do a lot of the hands-on exercise. Okay, so far you have any questions that you want to ask at this moment? Okay, no question. So this is how we do we find our p-value, all those. Okay, but you will learn about this next week. Okay. So so far any questions that you want to ask before we call out for today? Okay, thank you. All right. So you have no questions, then I think we shall end the session early today. Okay. So yeah, I will see you next Saturday. All right. So remember to attend the session, and at the end of the session, you will need to do the post test. All right. So thank you, everyone. Have a good day. Have a good
Yeah.
weekend. Thank
Thank you.
you. Thank you. Bye bye.